A warm good evening to one and all co-present here. On behalf of
On behalf,
Department of Hello,
on behalf of Department of Electrical and Electronics Engineering, PSNA College of Engineering and Technology, I warmly welcome you all to the 6-day online ATAL sponsored faculty development program on artificial intelligence and machine learning development in electrical vehicles and renewable energy system. We are delighted to have a distinguished dignitaries, resource person, faculty members, researchers, and participants joined today to us. Let us begin this auspicious program with a positive note and enthusiasm for learning and innovation. To formally commence today's program, I now invite Dr. N. Chandrasekharan, Professor and Head of Electrical and Electronics Engineering of PSNE CET, to deliver the welcome address.
Good evening to one and all present in the online platform for this 6 days ATAL FDP. It gives me immense pleasure to present welcome address for this 6 days ATAL FDP on artificial intelligence and machine learning applications in electric vehicle and renewable energy systems, conducted by Department of EEE, PSNA College of Engineering and Technology, Dindigul, Tamil Nadu. First of all, I like to welcome our chairperson, Thirumadi K. Dhanlakshmi Ammal, respected Pro-Chairman Sir, Rotarian RSK Raghuram Sir, our trustee Surya Raghuram Sir in absentia, and our beloved principal, Dr. D. Vasudevan, who is online with us for this inaugural session. Welcome, sir. I also
Good
welcome
morning.
all
Good,
the.
good morning. Good morning. Good evening. Good evening.
Okay, sir. I welcome and I extend my warm welcome to all the participants from various universities, institutes, and our internal participants for this 6 days ATAL online FDP. Hope which will be very much interactive and useful for you all. I take this opportunity to thank our management for their support in all the ways, and our respected principal sir for his constant encouragement and inspiration to conduct these kind of programs in our college. I once again welcome you all for this 6 days online ATAL FTP, and thank you so much. All the very best. Over to Saravana.
Thank you, sir, for your warm welcome and inspiring words. Next, it's my privilege to invite our respected principal, Dr. D. Vasudevan, Principal, PSNA College of Engineering and Technology, to deliver the presidential address.
Good evening, all. And it gives an immense pleasure to me to address in this online inauguration of ATAL FDP in artificial intelligence and machine learning applications in electrical vehicles technology and renewable energy systems. The FDPs are very essential because they give an opportunity to our faculty to have refreshments on what are all going on in the given titles, and also the title selected and approved by the AICTE is a ascendant, and also it is essentially useful for the electrical engineers who are working on electrical vehicles and its various applications and in renewable energy systems. Because artificial intelligence is a buzzword today, and without that, we cannot find many new applications because it paves way for new applications. When and all new inventions, a big inventions comes like electricity, when the electricity came a century back, it paves way for invention of many things, including motors, transformers, for transmission equipments. And on the after the fabrication of motors, it paves way for many appliances, including pulverizers, washing machines, mixes, like that. So many appliances had came to the existence after the invention of electricity. In the same way, the invention of internet created computers, and internet created a lot of applications like your email facilities and online ordering platforms, digital money transfers, etc., etc. There will be large number of applications. And similarly, now artificial intelligence paves way for the unthinkable new applications. And the focus of this FDP is to focus the AI and machine learning applications, in particular to electrical vehicle and renewable energy systems, is very unique. It is a requirement of the day, and you can find immediate applications. I think that after the completion of the short-term course, the academic members who are attending them will be fully enabled to use this AI and machine learning techniques widely in the electrical vehicles. The another thing in this title is, if a student or a faculty learns how to apply AI and machine learning in electrical vehicles and renewable energy system technology, it paves for numerous other application in similar application, numerous other similar applications in many other fields. So this is a generic topic, but focus on uniquely on EV and renewable energy systems. I hope that I had seen through the faculty list who are going to handle the classes, and it will be very good. It is very good also, and also it will fetch you much usefulness to you in your academic life to have your self improvement, and also you can reconvey what you had learned here into the classrooms, and it will pave way for new projects for our students. With these words, I congratulate the organizers for their untiring work in organizing this online FDP, and also I thank the AICT for their grant and their support for our institution. I also welcome the participants who had enrolled for this FDP. With these words, I convey my warm wishes, and again I'll hand it back to the organizers. Thank you.
Thank you,
Thank
sir,
you, sir.
for your motivate.
Thank you, sir.
Thank you, sir, for your motivating and visionary address. Now, to give an overview of the 6 days ATAL sponsored FDP, I invite Dr. S. Uma Maheshwari, Assistant Professor, Department of EEE, PSNA College of Engineering and Technology, to give a brief us about the online FDP.
Respected Principal, Head of the EEE Department of PSNA CET, dear colleagues and all the participants, a very good evening to one and all. It gives me great pleasure to welcome you all to the AICTE ATAL Faculty Development Program on Artificial Intelligence and Machine Learning Applications in Electric Vehicles and Renewable Energy Systems, being conducted in online mode from 2nd to 7th February 2026. In recent years, we are witnessing a rapid global shift towards electric mobility and sustainable energy solutions. Technologies such as artificial intelligence, machine learning, IoT, and data analytics are no longer optional. They have become essential tools in addressing challenges related to energy efficiency, system optimization, reliability, and sustainability. In this context, this FDP has been thoughtfully designed to equip faculty members with contemporary knowledge and practical insights into these emerging domains. Over the next 6 days, the program will cover a wide range of important and relevant topics, including future research directions in electric vehicles, digital twins for real-time optimization, machine learning applications in renewable energy system, predictive maintenance of EV components, AI-based solar energy forecasting, smart EV architecture with connectivity and AI integration, IoT-enabled monitoring of EV charging station, high power battery energy storage system for grid integration, and all. This inclusion of a session on industrial design and patent filing procedures in India further encourages innovation and research translation among faculty members. We are privileged to have eminent academicians and industry experts as resource persons who will be sharing their expertise, research experience, and industry perspectives. Their interaction will undoubtedly help bridge the gap between theoretical concepts and real world applications and inspire us to incorporate these advancements into teaching, research, and consultancy activities. This FDP aims not only at knowledge enhancement but also at fostering outcome based education, interdisciplinary research, and collaborative learning among faculty members from various institutions across the country. I am confident that this program will be highly beneficial to all the participants and will contribute significantly towards academic excellence and sustainable technological development. Once again, I warmly welcome all the participants and wish the FTP a grand success. Thank you.
Thank you, ma'am, for your clearly outlining the objective and importance of this program. To formally inaugurate the FDB, Dr. C. Bharati Raj, Professor, SRM IST Chennai, has joined us now. May I invite Dr. R. Saravanan, Assistant Professor of EEE Department, PSNA College of Engineering and Technology, to introduce our guest.
Thank you. A warm good evening to one and all co-present here. It's my privilege to introduce our today chief guest, Dr. C. Bharadiraja sir. Dr. C. Bharadiraja sir received his BE degree in Electrical and Electronics Engineering from Kumaraguru College of Technology, Coimbatore in the year 2002. And he is completed his ME in Power Electronics and Drives from the Government College of Technology, Coimbatore in the year 2006. He earned his PhD degree in Electrical Engineering from the SRM Institute of Science and Technology in the year 2015. He has completed his first postdoctoral fellowship in 2016 at the Center of Energy, Electric Power, Faculty of Engineering and the Built Environment, Tshwane University of Technology, South Africa, supported by the National Research Foundation (NRF). He later received the DST Indo-US Bhaskara Advanced Solar Energy Fellowship in the year 2017 and completed his second postdoctoral fellowship at the Department of Electrical and Computer Engineering at Northeastern University, USA. Dr. Bharadiraja sir also served as a visiting research scientist at Northeastern University, Boston in 2018 and as a visiting researcher at the University of South Africa during the year 2019 to 2020. He received the prestigious Young Scientist Fellowship from the Tamil Nadu Council for Science and Technology in the year 2018. He has been consistently recognized among the world top 2% scientists in the energy category for the 5 consecutive years during the year 2021 to 25. To the date, Dr. Bharadiraja sir has handled and currently handling 11 government funded research projects totaling for the Indian rupees of 21.77 crores funded by the premier national and international agencies include SERV, DST, ANRF, TDP, SPAR, MEITI, TNSST, and Indo-US collaborative programs. He is also a senior member of IEEE, IEI, and IET. Dr. Bharadiraja sir has authored over 280 peer-reviewed research papers, 21 book chapters, two books, and upholds 18 IPR patents. He has successfully enabled 5 technology transfers based on his research outcome. He is also the founder and co-founder of 3 EV startups and serves as a mentor to more than 10 EV companies in the areas of product validation, benchmarking, and advanced R&D. He is widely regarded as one of the India's foremost EV consultant, especially for benchmarking of EV motors, controllers, and powertrain subsystems. Currently, Dr. Bharati Raja sir is a professor in the Department of Electrical and Electronics Engineering at SRM Institute of Technology, Katangulathur, Chennai. He also serves as a center head for Center of Electrical Mobility at SRMIST, which is the India's first state-of-the-art research and ARAI compliant testing facility dedicated to the advanced electric mobility research and full-scale validation. We are very happy to welcome you, sir, for this inaugural session as well as the session one. Thank you.
Thank you, sir. Now, I invite Dr. C. Bharati Raj, Professor SRMIST Chennai, to inaugurate his program and deliver his lecture.
Vimala ma'am.
He will join within 5 minutes.
Okay, ma'am. Participants kindly wait. Sir will be joining within 5 minutes. Thank you. Bharat Raja sir, welcome you sir. Hello sir.
My screen தெரியுதா?
Yes sir, visible sir.
Okay, so
Yes, sir.
yeah. So first of all, I would say a small apology since I have not noticed this.
No problem sir.
So yeah. So till what time we have?
Till 6:30 to 8 sir.
Okay, fine. So let me take from my first slide, of course, where I am belong and about our Center for Electric Mobility. Then followed by I will cover the today topic, recent trends in electrical vehicle. So basically, I am in Katankultur campus. This is our one view of our campus. So our center name, Center for Electric Mobility.
Sir, can you switch on the video sir? I will take on screenshot.
Yeah, definitely. You're able to see me, right? So yeah, so this is basically this is our lab facility. We have full-fledged building for this center. Almost we are equipped now with uh, many instruments which are all mainly for development as well as testing. So we have been collaborated with top tier one automotive company and OEM original manufacturers, and we have been received nearly 25 crores funding from different funding agencies like DST, MIT, NRF Spark, and some other scheme as well. So my slide is moving, right?
Yes sir.
Yes, sir.
Okay, so basically, some of the unique feature is there in our center. So one such facility, what we have is to testing the wireless charger in dynamic in nature. So basically, dynamic in nature, and sense that the while vehicle is moving, we could be able to see our charging characterization and all. So as you can see that the blue color is basically it is called as the wireless charging road. Downside, are you able to see something like in the white color? This is nothing but the wireless charger. So such kind of capacity we have. So currently we are working with the dynamic wireless charging with a capacity of 11 kilowatt, but this capacity capable of going for till 50 kilowatt capacity. So this is one of the best feature we have in our center. And there are some ongoing projects with the wireless charger, something like charging for the scooters and some kind of battery related fuel cell. Of course, this is EVSC charger. Any charger to be validated with the dynamic value of grid, So this instrument will be help to mimic actual grid. Sometime we can, force our sag, swell, and all power quality issue. This could be help to validate vehicle to grid and grid to vehicle all aspects. And this is our hill facility. So hardware in loop is very important for neither to develop motor controller or maybe in microgrid or any hydrogen study. So we have a dedicated hill for motor controller, and as well as we have dedicated hill and with a dyno setup for testing the motors as well. So you can see these are the major portfolio what we are working. Of course, we are covering all the area of EV. Start with motor development, controller development, charging development, especially wireless charger. We are doing a lot of tier level product
and energy storage, meaning battery and as well as fuel cell. Then we are also working with charging infrastructure in a consecutive manner of microgrid and as well as nanogrid structure. And we do work with autonomous vehicle. As of now, we developed autonomous vehicle 3 category, which are basically used in off-road, not in the on-road. So we are experiencing with our campus, students commute, and we currently working with additionally digital twin and thermal managements, especially for motor and as well as battery. And we have very good team in power electronics converter for developing different kind of power electronics converters. So it is not only academic level research. Of course, we do develop a startup. So this is one startup currently they are in the market actually to manufacturing the motor and supplying. For your information, this company 3 years before got a fundraise about 250 crores. Currently, this company close to 2,000 crores company selling motors for MG, Tata, and so many companies actually. The list is very big. So I am very proudly say this is our BTech student. They have come up with an idea of developing a BLDC motor, and we are scaling into now for developing such kind of PMS motor, that too for a huge truck level, bus level motors we are developing. And in additionally, there is another company, Taurus Robotics. They are also developing a motor and as well as controller. But this platform is for axle flex. So the another before one, what I said, it's a radial flex. Apart from that, currently we are working with benchmarking of some EV with a full vehicle level, including wireless charger and as well as scooter level. So these are some of the pictures. So we have been donated this exclusively autonomous 2 vehicle to DST. As you can see, this has been given 2023. So now this is in the operation of the DST. And there are many companies we have collaborated. So I just added one picture with Stellantis. So Stellantis has donated 2 vehicles for research purpose. One we wanted to validate with the wireless charger, another one for poly-paste motor. Currently, this work we are doing with Stellantis. So the today outline is just I wanted to give some overview about the EV. You might have had many information from social media, and I do believe majority of students, faculty here, you could have collected so many information from different forum about the EV within India and outside India. Definitely, you could have collected some metrics also. So probably I am recapping, or I am going to tell some new information, and then different architecture of EV, that is very, very important. And then individual system level, how it is structured and what is the performance are expected. And end of the day, whatever we are developing in laboratory, that has to go to the market. So some of the compliances we have to follow, and what is the current market access in this portfolio, that we will see. So with respect to world, the one order is something like at 2030, majority of the automobile segment will be converted into EV. The reason very simple: people wanted to migrate because of fossil fuel dynamic pricing and renewable energy penetration. But very important, we wanted to make the green energy so that this carbon footage will be reduced. India, we are about during the COVID time, National Electrical Mobility Plan has been released. It's 2020. These materials are available. You can collect from the internet. But unfortunately, what happened that the COVID immediately came, so it is not kick off. But now, if you take after COVID 2023, we are about to start full fledged. Now, being 3 years, India has been grown to a very satisfactory level. So, what is that EV migration as a government is expecting? We wanted to develop our own subsystem. So what is called subsystem? Basically, for example, if you take EV, within the EV, powertrain will be there. Powertrain basically consists of electrical motor, controller, and battery. And to coordinate this, you need BMS and as well as power electronics converter. to make this entire powertrain. So as of now, we are not fully equipped with what I can say. We don't have a proper supply chain. It's not that every subsystem level, India.
Video is not available, sir.
Which one?
Not audible.
Sir, I didn't get you.
Video is not visible.
I'm not doing anything actually.
Sir, it's visible only, sir.
Not
Balamurugan,
visible.
sir.
Not visible, sir.
No, somebody is telling visible only.
Sir,
Yes,
it's
sir, our
visible
connection-
only. Could you please check
Visib-
your internet connection?
Balamurugan, sir, can you check the internet
okay.
connection, sir? Yes. Sir.
Okay,
Okay, sir.
okay, sir.
Okay,
Tell me.
so okay, no problem. So basically, the one thing is understanding. At now, we are developed everything indigenized way locally. No, but we are growing in a faster manner to make it everything as local. So as of now, frankly speaking, India is not manufacturing a battery. Maybe we are manufacturing battery with the cell chemistry taken from other country, but we don't have any proprietary cell chemistry for making or manufacturing the battery. But there are industries are rigorously working. There are startups also has been created in this. Probably it will take some time, but however, if you take motor and as well as the controller side, especially motor side, India is already self-sustainable. Meaning we are developing our own motor. Even there are companies working with non-magnet motors. That's very, very important because we have to reduce the cost and dependency of the other country who are having such kind of magnetic minerals. So the one line is India has to develop a own subsystem. It is supposed to be made in India. Then the very big problem in front of us is that charging infrastructure. So roughly, you just assume tomorrow morning everybody, maybe 10% of people having EV, then the provisions of those 10% vehicles for their charging is not available in our country. There are a number of reasons we can say. We have been developed our roads very tight way. Traffic is not supporting the parking infrastructure, even public and as well as private. Even the home also it is not proper. So there are a number of reasons are there. The charging infrastructure being deployed is getting delayed. But now the government has taken a lot of initiative and as well as policy. Whichever the new city developed or certain commute area developed, so it is mandated to have EV charging allocations for their vehicle to charge. Of course, public vehicle also can come and charge. Then this battery energy density is one straight formula we are expecting from battery, but provided the cost is also very important because 60% of electrical vehicle cost, maybe I can say 40% cost goes to battery. So the battery cost has to be reduced and confident has to come to the customer. The battery should not explosive, and the battery reliability and second life, everything has to be ensured. In such case, probably this could be a correct choice. So, and alternative options for the battery, something like fuel cell and all is another initiative. We have to be concentrate. Of course, the entire world is working on it. Then the smart city initiative, it is a parallel initiative driven by the government. Our government of India has been already announced every budget. Even this budget, I'm not expecting some smart cities are announced. But if you take old budget, there are 25 smart city. Even India, even our Tamil Nadu, there are some smart city has been announced. So basically, the smart city initiative, the EV is also attaching. Why? Because smart city initiative means it is not that to connect the sensors and create some kind of infrastructure. So smart city in sense that first of all green city, and secondly the EV and other provisions properly.
मतलब कि वही था मेरे साथ कहना क्या चाहते हैं मतलब
proper renewable energy and proper planning of integration.
Participants, kindly mute the audio.
All to be solicited in this platform so that it will be possible. So in together we can say like our government clear policy is 2030, 70% vehicle. I am talking about passenger vehicle, it's not commercial vehicle. Okay. So to be a EV, and there are lot of regulatory support, communication, supply chain, EV adaptation is already started. One ministry, intentionally working for that, that is Niti Aayog. Under that ministry, there are multiple ministries like Ministry of Heavy Industry, Road and Transport, and as well as Urbanization and Ministry of Power, intentionally working this fast adaptation of EV. So fast adaptation, there is another scheme in India. It's called FAME. Already we are fighting with China. I should not say like straight away a country name, but it's a real fact. So we have to be discussed openly. Nothing wrong. So majority of the components we are getting from China, but now we are slowly localized this thing. So in a point manner, the real game actually I believe that the real game exactly start by 2030. So what I mean to say, 2030 India is not only self-sustained in EV subsystem level, including battery, motor, and as well as charger, and of course power electronics and related semiconductor. We are also probably may create a floor for sending those EV components to other country as well. So that is the meaning I mean to say the real game will start. So automatically what happened is China revenue will go down. So India revenue will go up. So that situation makes better. But if you take 2024, some study is happening. This vehicle, ATAL is one such two-wheeler company suddenly come into market. They are getting into market capital near to TVS and Hero Honda. So these are giving evidence that the new startup also, India is growing up very fast. And of course, there are a lot of the policy document also declared by Niti Aayog. So it will be a good evidence for to make India is better at 2030. So probably this figure is indirectly said that India will be a front runner. It is not only using EV, it is also to give a supply chain component for the EV manufacturing. So basically, if you take EV, with respect to deployment, there are three segments. One is EV, which means vehicle segment. You all know that India almost, all vehicle production units we have. Like if you take a BMW, Benz, Audi, even for other, high brand vehicles are manufacturing in India. But the point is, those vehicles are in n number of vehicles are coming up. The charging infrastructure in India is not that much available, and the supply chain, especially battery materials and semiconductor materials, we are not that much good. But that is the reason the government is taking a lot of initiative to engage that commitment for the development of localization of EV. So if you take simple EV, it's not a very big actually aspects compared to the IC engine. This picture will be clear introduction for understanding EV, basically traction, batteries and power electronics, inverters, motors, and as well as some gearbox will be there for making any EV powertrain. So beyond some charger, particularly onboard charger, auxiliary battery, thermal unit, and some transmission. This is probably a light vehicle chassis unit. So these are things additionally is added. So different architecture will be there in the EV. So IC, everybody knows that we have a diesel or petrol tank pass through the engine and it will operating. Beyond, we have a different category to use the EV with IC engine. So probably we can say hybrid electrical vehicle. Many companies actually developing hybrid electrical vehicle. Even if you take Maruti is a very high, market capital has in India for selling the car segment, correct? But still Maruti, they are not producing a single or selling any single pure EV, but they're developing a hybrid EV with the Toyota. You all know that hybrid Maruti Hyrider and all, it's a very good vehicle actually. So basically in hybrid vehicle also, we have a battery inside and of course we have a motor inside. Whereas plugged-in hybrid vehicle, the battery is little higher. So what is the difference between hybrid and plugged-in hybrid vehicle? Plugged-in hybrid vehicle, you can connect the battery to charge from your external electrical supply. So the battery size also will high. So automatically the plugged-in electrical vehicle give a range better than the hybrid electric vehicle. It's all about the cost factor. So BHE is nothing but battery electrical vehicle. It's a pure EV, which is having only battery pack. it is not having any kind of petrol or diesel engine inside. So this is what everybody looking for. So the one huddled with us here is that this battery pack is not sufficient enough to survey like a IC engine. So petrol or diesel you can easily refill, but the battery cannot be charged very quickly, provided your range, you want to extend your range, you want to increase your battery rating or and as well as sizing. So if you increase the sizing, the vehicle cost will go high. So this is a win-win situation. Neither we cannot increase the size or the fast charging your battery has to be supported. So either of this way only this plugged-in vehicle, it's called pure electrical vehicle, gets succeed. So recent days, the focus on hydrogen based electrical vehicle, which means it is something like a hybrid vehicle only. Maybe petrol and diesel engine will be replaced by fuel cell, and then as well as battery. Through that, you can actually charge your vehicle. Okay. So as I already mentioned in the other pictures, through the some idea how it is EV, but this will be a clear picture how the car segment EV will be. You can architect. So basically, you have a traction motor, which means that will be used to drive the vehicle. Then for that traction motor, you wanted to control. That is nothing but your what do you call? Just a minute, I will take a highlighter. So this is nothing but your motor driver, which will be very close to your motor, and you have a battery. So of course, car segment, bus segment, any segment if you take, battery will be associated or allocated in the surface of the vehicle car body. So it is a floor mounted battery. Then of course you have a charger to charge this battery, and for the charger to connect you have an onboard charger, because always you have an AC supply or it's DC supply. Suppose it's AC supply, you have to use the onboard supply, onboard charger to convert into AC into DC. And then you maybe have an auxiliary battery. It's a small battery which will be used for electronic system and as well as door opening, closing, wiper machines and all about it. So traction battery is only to support the motor to drive. Okay. So this is what the general architecture of EV. If you see in other aspects, how the plugged-in EV will be there, again, as I already mentioned, there will be an engine and petrol or diesel tank, provided you have a charging point to connect the battery. In further, the question will come: is it a one motor or two motor or four motor? It's all about our what do you call requirement. So let me explain first what is that motor and where to be kept. So I take this figure. For example, the motor is connected in the front of the vehicle. It is front wheel drive. Front wheel drive. Why it is front wheel drive? Because the motor only going to give force for you to drive the vehicle. So that is connected in front of the vehicle. That is front wheel drive. And of course, the motor is connected in the middle, so that it will be connected in the mid of the axle. So it is called mid drive. Okay. Suppose the same segment you are shifting into back side, that is called back wheel drive. Why it is front wheel drive? Why it is back wheel drive? It's purely mechanical. And about I can say, if the car have the front wheel drive, you will be get an extra force, extra starting power. So I can say it's a sports mode performance. Suppose you wanted to connect in the back, it's a load performance. So vehicle will be classified into CV and LV. CV means CV, LV and PV. So CV means commercial vehicle. I can loaded vehicle and all about. LV means straight away it's a load vehicle. PV means passenger vehicle. Okay. So I assume this is a passenger vehicle. The best recommendation to connect the motor in the front. If the vehicle is a load vehicle or commercial vehicle, the best recommendation to connect the motor in the back. But whereas you can see this figure closely, here the motor is connected on the wheel itself. Look at that. The both front wheel, the motors and as well as inverter will be there. Whereas the back wheel, there is a single motor will be there. Correct. So this is the motor number 1. This is the motor number 2. This is motor number 3. So why it is? This is 3-wheel drive. Why 3-wheel drive? Because front 2 wheels are connected with the straight away motor, and independently this motor can operated by the independent inverter, whereas back wheel, one mid-drive motor will connected in the axle itself, so it's called mid-drive. So axle itself is connected, which means the mid portion is connected and driving this force into two wheel simultaneously by the motor, it is mid-drive. Or the motor is straight away connected on the wheel, that is called in-wheel. So the market now is going on in-wheel. Why I have to go to in-wheel? I can take a best example of four-wheel drive what we have now. You take the Mahindra Thar. Mahindra Thar is selling two Jeep. One is mid-drive, another one is four-wheel drive. Four-wheel drive is basically recommended for the high performance. So everybody expecting high performance vehicle. So what is it, high performance vehicle? If it is four-wheel drive, you can drive any terrain. Basically, it is not only operating in the road, it can drive in any terrain. You can take it into beach, you can take it into any hills area, you can take it into inside the sea, some dry rivers. So whatever you want, wherever you want, you can drive actually. And controllability also very, very high. Of course, cost will be high, but the discussion with the performance, the cost, and definitely when you want performance, the cost will be go high. Correct. So hope you understand what is in-wheel drive and as well as mid-drive. Suppose this whole portion I am removing, again, this wheel also connected with another motors, that is called it as all wheels, the motor is connected, so it is a four-wheel drive. So basically this is the equation. So electrical architecture, if you take any EV, it is something like any wheel, you have a differential. So why need a differential? Different speed allocations and all will be there. And next, you have a transmission. This transmission, whatever the force is coming from the motor, that is captured by the transmission given. Then this is motor. Here I mentioned BLDC motor, but you assume that motor it is, okay. Then the motor controller will operate the motor. Then the motor controller need a DC supply. Of course, that is coming from the battery. The battery need to charge. So you should have a charger. So that comes from DC-DC converter that could charge. And sometimes the super capacitor is also there in the vehicle. Whenever you are giving a brake to your vehicle, the existing EMF, back EMF or available magnetic field will be go into charge into super capacitor. Rather, battery cannot capture that amount of quick charging. So it is going back to the super capacitor. So super capacitor also started to discharge into battery. So battery only end of the day driving the motor. So all together it has to be operated. It's called energy management. So these all there basically with the any EV. So EV means there is no gear and all. So that you have only two pedal. One is acceleration pedal. Another one is a braking pedal. Whenever you accelerate, you will get a speed and torque. Whenever you get a braking, intentionally you are brake the motor by using a brake drum, but of course parallelly you are stopping your machine through the controller as well. Okay, so this is what basically the architecture allows do. So fuel cell also do the same actually, but rather keeping a battery, we have a fuel cell and connected to the motor. So rest of the geometry, everything is same. So you need to fuel the hydrogen either in gas or liquid or in solid form. Okay, so that's what fuel cell. So this is a picture of fuel cell. So how they are attaching fuel cell, you can see this cylinder is so danger. So the fuel cell cylinders, fuel cell means there are three work normally and an academician has to see. First, hydrogen generation. Okay, H2 generation, hydrogen generation. Hydrogen generation, hydrogen storage, hydrogen usage. So we are an electrical engineer, we can use the hydrogen usage, but very importantly, hydrogen storage and hydrogen generation is important. So hydrogen generation within vehicle, it is not possible as of now. There is no technology, but the entire world is working on it. But hydrogen storage is possible. We are all using a cylinders to storage. You cannot imagine this is 100 bar pressure, 100 bar, 200 bar pressure. So 100 bar, 200 bar pressure means it gets explosive, nearly half a kilometer get affected. So this cylinder holding huge amount of hydrogen, roughly about 20,000 liter hydrogen in a gas. Okay. in the gas form or in liquid form. So the type of cylinder, how do you manage the thermal and all, very, very important. So wherever the car body has a place, you can attach your cylinder. So there is some procedure will be there. So point is neither electric or hydrogen, you have to refill. So hydrogen filled by gas or hydrogen fuel. Electric means you have to fill the, what do you call, your battery. So just will skip some slide. So this is what the real, powertrain will be. You can see whatever these all small will be there. This is battery module. The whole system is called as battery pack. On top of it, there is unit called BTU, battery terminal unit. That's battery terminal unit gives DC supply to the motor control. So this cable, now whatever I am marking, this cable is actually a cable which will be representing for the entire vehicle. At present, entire industry is working. At present, I am talking about present in sense maybe at past 400 volt. Now in 2025 October onwards, all EV company are decided to go for 800 volt system. Why 800 volt system? In that to the case, you can have a huge amount of energy density battery and light amount of cells, so that your car body portion will be reduced to half of it. Okay. Question is that amount of energy density batteries, previously it is not available, now it is available. So that's the reason the industry move on to 800 volts. Provided when you go 800 volts, your cables are not highly intensive with respect to current. So your wire harnessing and as well as interoperability, EMI, EMC, all will be go down. So that reason the industry move on to higher voltage. It is called 800 volt system. Okay. So if you take the whole EV architecture, whatever I have discussed as of now, battery pack is the first segment, power electronics is second segment, motor is the third one, transmission is the fourth one, differential is fifth one, and thermal management for the motor, battery pack, and as well as power electronics is a common one. So then generally what you have to do, nobody go on straight away manufacturing the vehicle. First of all, they go for a model, each and every component they design, the model controller they will build, they'll validate in the hill and SIL and all. Hill means simulation environment, hill means hardware in loop environment. Then component by component they will interface in the vehicle body, and then whole vehicle they manufacture. Then they will involve for the testing multiple times. Then only it is come to the market. You got it? So now I am going to tell some what are the futures powertrain will be in market. So hereafter in sense it's already started. So company called ZF, they are doing this. So as of now, what happened? This mid-drive motor will be something like this. Correct? You see there is a wheel, shaft, the mid-drive motor will be here. So this whole portions, 3 to 4 OEMs will be there. OEM means original equipment manufacturers for a system to develop. Okay. So assume that this is a system. There are multiple OEMs put together working. For example, if they start by today, they will end up this project by 2030. So that is not a case to do hereafter. It has to go very fast. For that, the powertrain itself, they are actually developing segment by segment. So mechanical powertrain model and electrical powertrain model. So electrical powertrain model, what I am showing here. Mechanical powertrain model is probably spring and braking system and all about. As you can see here one motor will be there, here one motor will be there. These are the system will be connected to the vehicle body. You can straight away connect this item into your vehicle, make your powertrain in a shorter time. Okay. So you can see this. There are motors are engaged here. This is what the current system, what we have available. So but the market is going on this kind of systems. So this is the way how the mid drive is connected in the truck. You can understand. So the truck mid drive in the middle portion, and both side you can connect your wheel and you can operate individually. You have a brake drum and other kind of mechanical connectors. So this is also a proof of concept by AVL. Again, the whole system will be available. Just you can make your platform. You straight away to connect. Just this what do you call this orange color? You connect in your battery. Enough. Rest of things you don't want to do, and this portion will connect for mechanical system. And this is already disc brake will be there. You can engage with the electronic system to go for a disc brake. So you see, this is what the system, the similar system only what I explained. I'm just focusing in the blender drawing for your further understanding. You have it typically weight balancing also there. Right. This weight, this is not, you don't assume that it's a weight balancing. Actually, it is a hydraulic system for suspension. So go for a special suspension. This suspensions include double layer. One is hydraulic, another one is this electrical linear actuator. With that, it will operate in a millimeter range of suspension. So these all available. Okay. So then, how this fit into the bus? You see, very huge bus. The portion where the wheel is connected and motor is connected is very, very, very small. So this itself is understanding. This will be iron technology. This will be engaging with all battery operated vehicle, fuel cell vehicle, trolley system or compression engine, even for hybrid system also you can use it. So this will be a fuel cell, of course, for a car, how we are attached, but the buses and all it will attach the top because the portion is empty there. Okay, this is also another fuel cell items. So yeah, first for understanding, I'm just having some figures to know about how the motors are connected. So coming to battery, so as I already told, the battery is connected in the platform. So battery means battery cell, then battery module, then battery pack. So number of cells is module, number of module is actually pack. You can see this is module. No. Number of module and number of module combinedly it's called number of pack. So basically this is one pack, this is another pack within that module. You open the module, furtherly what is there, it is cell. I will show you later, okay? Probably I can show you later. So I said about in-wheel drive, no? So mid-drive motor, you all know this is mid-drive motor. Any motor, very, very important factor what you have to see is a rated power. And second one is a peak power. The question always there, what is peak power and what is rated power? Assume my car is moving in this road. So my cursor is a car moving in this road. Okay. Here there is a portion speed breaker. Here there is a portion is a hill. So now my car is moving. So this is a flat road. I could derive the power from the motor is the same. It's a rated power. Suddenly I am going a speed breaker. I need extra power. Correct. From what? From motor. What is the formula? Basic formula for motor. P is equal to 2 pi nt divided by 60. So anyway, here what you need? You need not speed, you need torque. Provided going with the same speed. So you want to draw the extra power. Who will give extra power now? Motor has to give. Then you need, already you are working in rated power, nominal power. So you need some extra power now. So that extra power probably some power beyond 25 kilowatt according to this motor. Maybe I assume that 30 kilowatt. The speed break even higher, maybe in this area, you want 40 kilowatt. So you don't want power always. Your intention to operate the motor in the nominal power only. But you need a peak power also. Only 2%, 3% chance you operate in the peak power. You always operate in the nominal power. But unfortunately, the design always you do with the peak power. Then what is the net efficiency then? It is less than 60%. For the design I'm talking about. I'm not talking about the consumption efficiency. But we have to do some new technology may come with attaching both. Speed also the same. We have two speed. One is nominal speed, another one is peak speed. So this is very important factor to know into motor. So what is in-wheel motor? In-wheel motor means your motor, power electronics converter, controller, brake, what else? Everything is there within the motor itself. So that is call it as in-wheel motor. As you can see this picture, all are there in the wheel itself, wheel drum itself. This picture give even more information. You see, this is wheel, this is your case. I just connect the motor here and attach my brake shoes and disc brakes. So in such a way, you can build your motor within the vehicle wheel itself. Now you see the powertrain how very simple way. So this is what the present technology on the what do you call in a powertrain. Okay, so it's called in-wheel drive. So basically, car body will be so simple then. So you develop your powertrain and superstructure and other aspects. These are already available in the market, right? The very clear picture is also available. Okay, so basically this is in-wheel motor. You can see within the wheel itself, powertrain, stator, rotor, bearing, everything will be there. Okay. So see the suspension for the in-wheel motor. So basically, now the market is moving on this kind of suspensions. So initial suspension means normally we have suspension straight away to connect to the car body. Now this kind of suspension are recommended. It is there in aeroplane basically. So what it will help now? You see the wheel of the vehicle always operating 180 degree. Even now, no wheel operating 180 degree. It's all about 70 to 80, even lesser. But this wheel capable of going for 180 degree. If it is goes 180 degree, then you can vehicle can park in the vertical position. So this is a parking area. The vehicle is coming. Vehicle always go here and go here and go here, and then you got to go back. But in this case, vehicle can come here and go inside. Okay. So the in-wheel motor, I said no. The in-wheel motor in permanent magnet synchronous motor, PMSM motor will be classified into two. One is radial flex motor. I can call it as radial motor. Another one is axial flex motor. I can call it as axial. So this is axial motor, that's called in-wheel motor. The size is very, very small that you can connect in the wheel itself. Okay. So this is the difference between radial and axial, how it is working. So radial machine, basically you have a stator with the throughout the pole pitch, and the winding is also totally continuous winding, distributed winding. Whereas axial flex is a concentrated winding. It will be scattered like within the pole itself. So that's the reason the axial flex are size and small. But there are a lot of challenges is there for axial flex, particularly thermal handling and other kind of issues also there. So currently I showcase some what we are doing. I'm talking many things about the motor, right? So currently we are developing through one project 40 kilowatt motor. So what we have to do that we have to reduce the magnet. So magnet is very, very important in the motor, but with respect to the cost, the magnet is the most culprit. Why I'm telling culprit? Because the cost of the magnets is very high. The magnets also locally not available. If you take India, we are not manufacturing any magnets. It's all coming from China. China is so good in manufacturing of the magnets. China don't have much mining actually. Mining is there in some other country, but China importing minerals, and they're creating a manufacturing facility to manufacturing the magnets. So neodymium magnets is used basically for the permanent magnet synchronous motor, especially for EV neodymium 45. It's high-end grade. So we could take an opportunity to design a motor such a way, at least to reduce the rotor magnets, which means rotor only having a magnets actually. 23% target we have fixed and we have reduced it. And stator copper loss also we wanted to reduce, so such a way we can design 10% copper winding itself we are reducing. Then we developed 400 to 600 volt traction inverter. With that we are driving this motor. Finally we have to bring a system like this. It is inclusive of controller, motor, and as well as gearbox. So now we are working on it with this system. And these are some of the evidence. Maybe I can why I am showcasing that. Just wanted to understand how stage by stage it is going on. First, any motor when you develop, you have to concentrate how your rotor magnets are positioning with respect to what is your performance curve you are going to bring. Any motor speed torque characteristics curve is very important. Once you are done with the ANSYS analysis, then you have to go for reliability with respect to magnetic performance improvement and as well as thermal performance improvement. Then you can go for rotor core design, stator core design, winding, then we can pack the magnets, pack the motor. Okay. So this was the procedure basically. How do you do that? It's all real value what we are developing. Okay. So we are also comparing with that. Some of the results I have mentioning here, how transient performance and steady state performance these motors are giving validated. This has been tested in the system. These motors are tested in our lab actually. So you can see the student is testing with continuous performance and as well as discrete performance. So we are continuously validating with a different range. So it is operated to the power supply. Of course, the power supply will be mimic like your battery. Okay. So yeah. Then coming to battery, as I already promised that I am going to showcase that how the battery pack and module and all. You can see this is the battery pack. Once you remove the battery pack, the inside battery pack, you have a battery module and as well as cell. Okay, and the BMS also there. Now look at that. Cell will be have a 3 type or 4 type, I can say. One is cylindrical cell, another one is prismatic cell, another one is pouch cell. So now the cylindrical cell is this one, prismatic is this one, and pouch cell is this one. Pouch cell, what you have in mobile phone. Now entire market is focusing on pouch cell. There is one reason will be there. Anybody know the reason? Those who are attending here, anybody knows the reason? Even one student is sitting with me, listening all. You know the reason? No reason. I will tell you the reason. So the pouch cell is designed such a way, very lightweight material. Point number one. Any pouch cell, you can take in your hand like a 5-star, what do you call, Cadbury's chocolate. How you break? No. Likewise, maybe you can not that much very lighter, but you can easily handle. It's not weight. And secondly, the pouch cell, the anode and cathode material what you are injecting with the lead will be very thin. The requirement is thin only. But since we are going prismatic and as well as cell, we are making high composite configuration. We are doing it. Whereas here it is the thermal penetration happening this area will be reduced. Whereas thermal penetration for this battery and all is something like this during your charging time. So because of that only reason, pouch cell is now emerging into market. So all OEMs, automotive industry, all are now working with only pouch cell. There is no prismatic cell hereafter. Maybe auto, rickshaw and all we can do it. But all car segment, all will go to the pouch cell only because of this advantage. Weight and as well as thermal penetration, anode and cathode material point. So now this is a single cell and you can combinedly do, it is nothing but a module. So that module you can put it into the case. Case has different mechanical aspects, then you can pack it. So this is what basically procedure. You can see battery pack, BMS. Okay, if you open, you have a different This is basically prismatic, a pouch, so you can understand. You open this module, you have end cover. End cover again, it's for thermal safety. Mechanical safety. Needle. I already told you, it's like a Cadbury's chocolate, so you can easily, for any accident, it will damage. So some needle pressure is needed. No, for that it's added. Again, this is also composite material with the help for cooling also. PCM material, phase changing material. Then the module, if you furtherly open, you will have a different pouch. So any cell, if you take, the cell value will be designed. As of now in the world, it is 0 to 6 volts. Okay. So lithium cells are available. Now sodium cells are getting emergence. And there are other cell, nickel, other combinations also. So why lithium we are using? No, because lithium only having near to, not 6 volt, near to 5 volts. Other cells are 2.7 volts, 2.8 volts. So you need number of cells higher for making a battery pack, for making a particular voltage level. That's the reason lithium batteries are used. So, as I already told you, 0 to 6 volts. So current rating, AH, I may say, recently we are testing one company, so I will take that value. It is 800 amps pouch. So one pouch, 5 volts. Let's say take 5 volts, not 5 volts, like 4.6, something like that. But I will take 5 volts, 86 amps. Then it is 800 volt system. Of course, you will be have 40, 160 series you want. Nearly 800 volt system. Then 86 amps current. So likewise, you can create module. Then all together electrically you can connect. You will make a pack. So end of the day, pack will be like this. So this is for bus. For understanding, I am showcasing. For a bus, normally pouch cell they will not go because pouch cell is so costly. It may be prismatic. So this will be one pack. This will be another pack. This will be another pack. This will be another pack. When you put the electric gun to charge, all will charge simultaneously from the EV power. But it's all having a separate connectivity while charging, individually discharge. We are thinking that all are charging combined. It's not like that. It will all charge separately. Every batteries have their own BTU in here. Each BTU have a BMS. Those BMS is called as slave BMS. And there is one master BMS will coordinate this everything while driving, not charging. During charging, master BMS don't do any job. Got it? So if you open the bus backside, you can see the battery other side. Mechanically, you want to remove, you can remove this side. But electrically, you want to charge, you can charge this side. Understand? Yeah. So you can even keep a battery in the top also if you want to provide the extra range. Of course, you are cool. So there. Okay. So I just skip something and instead I go to the battery management system. So take it any battery management system. It is duty to manage the cells and battery pack and module, provided thermal and other reliability and measurement of the SOC, SOH and all about. Now recent days, almost 1 month, people are talking about battery Aadhaar. Anybody knows about it? Battery Aadhaar. Participants, anybody knows what is battery Aadhaar? I don't think that anybody have idea. So globally, there is a term called battery passport. Read about it? So battery Aadhaar within India, battery passport, entire world. It's very simple. You have a passport, it is easy to understand where you went, when did you enter the particular place, when did you came back to the country. Am I right or not? So likewise, Aadhaar enter number itself, they will understand you everything because KYC will be there. So when the customer is buying the battery and is going for a service, he is fighting with Ola sometime. Why the charging happened and why this all happened? Because there is no proper data within that. So India recently announced there is a battery Aadhaar who is the seller, no matter which car company it is, the seller, manufacturing date, packing date, correct, selling date, vehicle first time charge, second time charge data, likewise how many times you are charging, where you are charging, what is the service you have done, what are the components you have taken. 5 years later, you are selling your car to somebody or selling battery alone to somebody. Those data, 7 years later, battery life gone, then the battery will be given to any stationary application, something like a cell phone tower, data center, or energy storage system. It is for battery second life. And even later, the battery materials are taken out, going for a recycle process. Till then, all data will be stored. You got it? This is called battery Aadhaar. So battery Aadhaar, who is going to take a major role? It's not a battery, because battery you cannot have a chip inside. So within the battery, what is the BMS is available? That is nothing but your KYC. I may say battery Aadhaar or KYC, both are same. So your BMS, KYC BMS, we have to develop. Now we have started already in your lab. Tomorrow or day after tomorrow, I am going to post in the LinkedIn that KYC BMS, which means whichever the battery you have, we are ensuring that there is one KYC to be done. That KYC store every data. So, like what is your SOC, while you are buying in the very beginning time, what is the degradation happen, how many times you serviced, any particular component you changed, whether you are charging properly your vehicle or not. So all history will be saved. Of course, that is active BMS. Now coming to charger, there are two kind of charger. One is direct charger, another one is battery swapping. So battery swapping is, though it is very good idea, but it's not a good idea for beyond scooter. So I'm not going to talk about anything on battery swapping. But direct charging, there will be a plug-in charging, wireless charging. If you take wireless charging or plug-in charging, there are some requirements you need for developing a charging infrastructure. One is charging infrastructure, type of charging, communication with respect to EV and grid, sockets and vehicle coupler, internet, everything is needed. So all together, you may be designed. So onboard charger, in sense that you are available with the AC supply. Available with the AC supply, you have some battery BMS inside the vehicle. So you have power electronics converter where PFC, rectifier and some charging unit to charge your vehicle. So at present in market, the chargers will be available AC and as well as DC. So if you have AC single phase, yes, you can charge. You have AC 3-phase, you can charge. It's very simple. Assume that there are 6 pins will be there. Plus and minus, this is engaged for the DC charging. So this is neutral, RYB. Suppose single phase charger, these two will be engaged. Or if it is 3-phase, RYB will be engaged. So whatever, so AC will be available, then onboard charger, DC will be available. This is off-board charger. So there are some standard will be there for charging. It is also there for motor, but the motor it's not that much. But charger, there are a lot of standards. So SAE is nothing but Society of Automotive Engineering having a standard for charger, for communication, coupling, and all about. Likewise, internationally we have standard called IEC and IEA, and some radiation standard will be there. That is NFPA, and IEEE also have some standard. So the key strategy for any charger, it's a mechanical design. That's very, very important. Then EMI, EMC is also to be addressed. Then performance, which means voltage, current regulation, efficiency, and fault recovery. And environment also, the IP production. IP production means, for example, if you take wireless charger, water, ice, all will be appear in the road. Charger will be on the road. So you have to protect properly with the shielding. IP means IP65. It will be a standard for testing with the rain scenario. IP67 and 68, it's for flooding scenario. So all to be tested, the humidity testing, cycling testing, thermal level and salt testing, even needle testing, pressure testing. There are so many testing will be there. You have to do that. Then electrical safety, installation testing, ground testing, and overground production testing. Now, recent days, people are very concerned about cyber security testing as well. Why? Because, as I already told you, KYC of battery and all about. Likewise, anybody can easily enter into BMS. They can give a malfunction data to the BMS to operate the vehicle battery by BMS. So total company can be collapsed. It's very simple. Even I can do. Why a cyber security crime people can do? So simply you can enter into BMS, go to the threshold value, change your threshold value, enough. Automatically everything will gone. Am I right or not? So the battery life goes down, or even sometimes you can blast your vehicle also if it is wireless charger. And there are some interoperability issue will be there. So what is basically called interoperability issue? This is very, very important factor. Mainly this academic people are not bothering about this interoperability issue. See, it's very simple. When you take a what do you call license for coordinator என்ன பண்றாங்க? So if interoperability means
John sir, could you please mute your microphone?
so for example, okay, for instance, what I said, interoperability, right? So how can I say, you are taking some supplement for your bodybuilding. When you take supplement, that's build your muscle through the protein. That's everybody knows. But there are some side effects also will come, I assume. Likewise, when you have a wireless charger, say for example, or any kind of high speed motor with having a what do you call a high intensive magnetic field winding, that field winding will affect your vehicle other sensor, because the sensor will operate 1 megahertz. Your vehicle will be this all motor and wireless charger and all other onboard charger, they are having inductor inside that will operate in other frequency. So this will affect that. So entirely what happened, this scenario fails the sensors internally or can control internally, the information will be exchanged. That's called as interoperability. So that could be very much challenge in developing an industrial level product. So so what do you call, I may say this what do you call this interoperability to be addressed. So another charger, I just wanted to explore this. It is called pantographic charger. Now I am 100% sure this will be a solution for India local bus service segment. Why I am telling you, this is already experienced in Japan. For this pantographic charging, you don't want the highest level of infrastructure. Just you have a pole on the road. I assume you take this green bus parked in Japan road. There is a learn. The bus will be stopped. Then there is a pantographic lift will come and attach in the bus. During the time the passenger get in the bus, get out the bus. High amount of voltage is 11 kilowatts of system. After that, the bus have a transformer on the top that will be stepped down and go to the battery to charge. So 1 minute battery, 1 minute to 2 minute battery get charged. But likewise, bus will be stopped so many places. So throughout the day, bus can operate. A shorter distance, shorter charging time. It is called pantographic charge. This is what basically architecture. I don't have much time to explore this, but I will show you the amount of pictures how it is supposed to be. So this is what the way to operate. The bus driver will give some signal, automatically the pantographic motor will come and attach this. So this could be highly possible like this. So bus stand, no, nothing to do. You just park your bus, create some pole over there. During the time of bus parking, it will get charged. You look at the cost, nothing. There will be a big transformer already available. Just to give only wiring is enough. Some infrastructure to be addressed. It's already there in Japan. This is called pantographic charging. Okay. So this is wireless charger. Even is better than pantographic, I may say, but the cost wise and some kind of handling issue will be there. It's nothing bad. When you charge your vehicle get charged. That's what the concept actually. So the wireless charging, according to my perception, South Korea is better than any country. So they develop open lane EV bus wireless charging. It is available anywhere in the South Korea. The bus will go and park in blue color line. It gets charged automatically. So this is the structure what they have actually. There is a orange color and red color pad. No, the red color pad is a receiver pad connected to the bus. The orange color pad is put on the road. So likewise, so many pads also you can attach. So that bus car body is bigger, no? So you can attach many things. The road also already there. They are already built in UK. So Renault has tested. But in the future like this, future will be is no longer all road charger will be connecting into wireless charger. A certain portion of charger will be there. So as you can see, there is a car here. It is about to cross a certain portion. Here, huge amount of current will be passed through the car. Flash charging concept. Then later car will go certain 5 km free. Then again get charged. So during the motion itself, you can charge, but a lot of research is happening in this area. Let's see how it goes. So wireless charger again static when vehicle parking and vehicle moving, you can charge. But this is highly proved, but this is not highly proved because the formula is equal to E is equal to dP by dt. Rate of change with respect to time. Time is here is vehicle speed. The vehicle speed is increased automatically. The denominator will be get increased. So numerator will be, the net value will go down. Correct. So vehicle speed get increased in the road, the charging will be get reduced. So you have to go slowly. So that is the only hurdles in front of us. But now people are talking about, it's very funny, while vehicle is going, another vehicle getting charged. That's called vehicle to vehicle. At present, vehicle to vehicle will be there in wired way. But people are talking one vehicle is going backside, you can follow another vehicle, you can get charged. But who knows, this is also possible very soon, practically. So we developed so many things in wireless charger. So as you can see, scooter, we have done demonstration. This we have migrated to real scooter. Car, initially we have done demonstration. Now we are built the hotel system in the car and some of the pictures for your information. So what my student is doing, we developed on POC that the scooter just park, he has a card, you just swap the card, automatically the vehicle gets charged. Okay, so these are the tile we developed for that. It's wireless charging tile. In your home, you can replace your tile with this, you can charge your vehicle. So what do you needed? One tile and as well as one power electronics converter you have to buy. For a scooter, we are experiencing with actually this is goes as a startup. We are experiencing for 25,000. Any scooter, they are supposed to spend money. They can convert their vehicle into wireless charging vehicle. It is 3.3 kilowatt, so that vehicle will be charged for 5 hours time. So now presently we are working for a car also. Initially we are testing with the buggy because it's very comfort to test actually. So now this testing is going on with the wireless charger. Not only for static, we are working with the dynamic also. These are the experimental setup what we have developed for that. So basically we have extensive instrument to calibrate all the flux carrier path and all about. So first experimental setup has been done. Then we are moving into vehicle level integrity. And we will go for a, the calibration of coil, foreign body, magnetic field, and as well as the temperature and all about. So these are the final product what we have developed. So this is under MIT project. So wireless tile is ready. Grid connected inverter is ready. Power electronics converters for the input power factor control is also ready. So this is a whole small circuit for charger. And presently we are working with 4 coil simultaneously like this so that the scooter can charge with one coil, whereas the car is parking with the 4 coil, the car also can get charged. That kind of system we are building now. We are also developing the application to take a pilot study in your SRM, attaching maybe a 10 scooter is wireless charging. They can book a particular lot and some EMS and as well as some payment gateway we can produce. So this is what is it? So the intention currently what we are working with Sterland is it is 29.42 kilowatt battery wireless charger. And Renault Liquid again the same thing like 26.4. The Renault Liquid is not available in India. It is coming from France. So probably it will come before this June. And we are also working with ATAL and planning to showcase some wireless charging for ATAL Ritz. And of course, the buggy model as well. So fuel cell, we are working many things. Well, let me understand something like what we are doing. So this is our fuel cell. So this is basically fuel cell means we have one PMSM PFC membrane. We have hydrogen, and this rest all the portions what we wanted to put into the vehicle. So basically, what we are planning, we want to develop one vehicle with a 30-seater vehicle for 30 kilowatt fuel cell. So it is again converting into IC vehicle to fuel cell. So just we wanted to demonstrate. So for that we already developed one small vehicle. Actually, it is called as lab experiment vehicle. So totally we are engaging with fuel cell type 2 cylinder, 5 kilowatt capacity. We are able to run this car actually. Okay, so I think we are also working with autonomous vehicle. I'll give you a small introduction. So the autonomous vehicle in the sense that there is no driver, of course. The point is, this is a big picture. So when you think on autonomous vehicle, but rest of things all are very conventional and continental. Whatever you can, even you can park your Benz car near to this, car coming to discuss with an autonomous vehicle is nothing. Which one? This your Benz car is nothing. They may have ADAS 4 also, no problem. It's nothing. Correct. So it is all imaginary count because it's not being developed. People are talking about AI, many things, right? It's not being developed, but nobody can stop. It will become very soon. A vehicle without driver in this huge Bangalore and Chennai, Delhi, Mumbai traffic, it will go. Uber is company maybe can operate within India for the city. What do you call Uber's? What do you call cab service? Nobody can stop this. Since this autonomous growing and AI also growing, correct? So what is needed? You have to include the AI, and this is very important because autonomous vehicle cost to be very high. Whether this vehicle making income or not, that's the only thing we have to work it out. So whatever. But anyway, we are academic research. We don't want to bother about whether it's make money or not. Let us start to bring some technology. But industry, of course, it has to be. So yeah, there are multiple vehicles, autonomous vehicle. So we have to develop some digital twin to handle the battery operations of each and every component because initially the driver get a alert signal. Even for oil is less, we will get an alert. We will replace the oil at present. But once there is no driver, who will handle car cleaning inside what happening? Components will influence and all about. So there should be a digital twin. So what is a digital twin? Anybody know what is digital twin? No idea? Okay, so digital twin is nothing bad. Today I am late 10 minutes, right? This what do you call this FDP program. This is my mistake that I am not noticed. I thought it's day after tomorrow, but anyway, this is my mistake. Suppose if I have a digital twin, I dictate my digital twin to take this entire seminar like me. You got it? I have a separate twin for me. The twin will do the respective operation. Let me do another operation. This is called digital twin. So a perfect model can be made. That model can mimic further. So that's what digital twin. Of course, the digital twin will be engaged, the battery modeling and other aspects. Okay, so of course sensor is also getting a lot of role. Sensor, digital twin, all together only make autonomous vehicle. So somebody wants to take a picture, those who are doing a research in AI and what do you call some kind of autonomous vehicle side or electrical vehicle side, with the inclusion of AI, I have been prepared this slide. What are the AI tools you may be used, you can use it, but what are the way you can use AI? You can use AI likewise. You can take screenshot if you want. You can plan for your research by using AI. So what we are done in our campus particular area, we are mapped.
Sir, can you show one more time, sir? Previously.
Yeah. You can take a screenshot.
Thank you, sir.
Okay, so what we have done, we have developed an autonomous vehicle driving with minimum autonomy. Why I am talking about with the minimum autonomy in sense, our campus more than 1 lakh students will be there. Of course, I am also having intention to go further, but I don't get a proper trial track. So we are getting a vector path, mapping everything. We develop an autonomous vehicle for campus commute. I will play. I don't know why I'm not able to play. Oh my god. So basically, this is a video. I am not able to play. So this shuttle we make it as an autonomous. Don't think that I am connecting steering. It's for safety. So it will go with the prescribed path. As you can see, this is where there is no steering will be there. So our students are testing the different level of testing. So since there are a lot of NDAs within this, I cannot show more than that. But of course, we are very good in autonomous, and we are developing something for some defense purpose. So, so that's the reason we are not able to show. So what we have done is that it is we will create a map, 3D map. It's a vector map. Within the vector map, we will set up the target area. So as you can see, this is the target area what we have set. So within the target area, the vehicle will go beyond. Within the map, whatever the floating value also, it will go and take operate. So that is way it is normally working. So even we tested with the other way also. Let me check whether that slide is available or not quickly. So these are autonomous vehicle what we have developed. You see, we are totally disengaged and putting into all removable steering and all about. I think system get hang. Huh? Yeah. So you can see this is what vector map. Anything I have. Sorry, I don't have that any video. Maybe you all know my LinkedIn, no? Bharati Raja Chokkalingam is my LinkedIn. In LinkedIn, I have demonstrated all the videos. You can see. Okay, so my LinkedIn page is Bharati Raja Chokkalingam. So from that you can take it. You can see probably you can understand. Yeah. So with this, I'm concluding. So our success story is very simple. We want to build our own vehicle, inclusive of all our own system. But of course, I don't have any capacity to build a battery pack right from the battery powder. But now we are working with one company for developing a battery module with their cell actually. So BMS and all, but not a battery cell. Okay, so leave the battery cell, rest everything. We are inclusive, and we are now developing a vehicle which is capable of going autonomous vehicle too. And I'll proudly say this could be a benchmarking value for one of the benchmarking value, not only one benchmarking value for autonomous vehicle for the country. So yeah, so with this I thank my major financial contributor and supporting structure from DST and as well as my team. So because of their fund and all my team, we have reached this level. So I hope so we will continue the same. So now I am open for the audience to discuss something.
Sir, good. Good evening, sir.
Yeah, good evening. Go ahead.
Sir, I am a researcher, sir.
Mm.
I belongs to the topic regarding bidirectional V2G converter.
Mm.
By implementing AI to meet out the grid stability and resilience, can you
Okay.
give some ideas and tips to progress my research in to next level, sir?
Okay, you get my WhatsApp number to the what do you call your coordinator. Okay, or I have WhatsApp number also. I just because in this forum I cannot explain. Okay, it will take a lot of time. We
Okay,
will,
okay, sir.
yeah, we do conduct a workshop very soon. In that
Okay, sir.
topic will be covered. Okay, so this is my email ID. Okay, just quickly I will put my email ID. You can write email also, or you can WhatsApp me. Don't get immediate reply, but I will do reply. Okay.
Okay, sir. Sure.
So,
Sir, another one thing, sir.
tell me.
Sir, you can show your email ID, sir. I will take a screenshot.
Yeah, this is my email ID. So please don't call me. Anybody wanted to speak to me, please WhatsApp me. I will call you. Your requirement with your requirement. Okay.
Okay, sir. You have told that you are going to conduct one FTP, sir. It is an online mode or offline mode, sir?
I never go for online mode anyway. Only
Hmm.
offline. Only offline.
Offline. Okay, sir.
We
Sir,
will run lab also.
another one thing, sir. Regarding EV, how to simulate in MATLAB, where I need to search and how the tools required to simulate the EV things, like that I need to clarify, sir.
I will just show one thing to my 1 minute. Just a minute. I may miss this. Is very good. I who's explaining that. Just a minute. Okay, so first I will complete this. You ask me now. Let me tell the participants how do you see, because many videos I have, but I don't have a time. You just go to my LinkedIn page. This is my LinkedIn page. I
Oh,
recommend all of you to note down this. This is my LinkedIn page. You go and give a accept. So I will connect you so that whatever the post I am doing, you can get it. Even for your answer, your question, the answer is there. So I just tell all the participants, please note down my LinkedIn page. Okay. In my LinkedIn page, just click LinkedIn page, go to the post. Okay. In this post, normally that this and all will be there, but mainly when we are conducting workshop, free workshop, and some kind of what do you call activities, all you can see. So basically, let me go to, yeah, you can see like our dynamic wireless charger post, and as well as video I have post. You got it? How students are
uh,
working and all, and
yes, sir. Yes.
there are some. I come to your question. There are some motor also. You see, this is the recently we have developed one motor and launched. And likewise, you can go through and you can understand some of the videos we are demonstrating. See, the entire whole uh, fuel cell system are explained. So now coming to your question, uh, yes, 1 minute. Okay, let me go to the video. So straight away we can explain. 1 minute. So you go to the video. Yeah. So I think this could, you can see this is what hill. Are you able to see? My students is explaining.
Yes, sir. It is visible, sir.
It is visible. No, my student is explaining something. It's basically called hill. My cursor is visible.
Yes, sir, we
Yes,
can
sir.
see.
Yes, sir. Visible.
So whatever your MATLAB file, you can put here
Ah.
in the hill, you can validate. You don't want to develop hardware. You got it.
Oh.
Say for example,
Okay.
you said now vehicle to grid. So entire
Yes.
simulation is done. That simulation you can upload here. Internally, it has an inverter. battery pack emulator, everything is there. So it is called basically HIL, HIL. So what we have, microgrid PHIL, physical hardware in loop. So through this, you can actually you can put your all model. So this is what that last 6 months before the faculty all came and many are NIT and this guy and all NIT basically. This guy, this all maybe NIT people came. So likewise, we will give a demonstration. So you maybe attend our workshop, will be get some clarity. You got it.
Yes, sir. Yes, sir.
Through my
Sure,
LinkedIn,
sir.
you can understand. We have put so many videos. I guess you can go through it. Even some more hill also there. I guess. I think this is also one more hill. So he is explaining charging emulator. How charger will be emulated. You see, wait. You said vehicle to grid. No.
Yes, sir. Yes, sir.
You see, this is what he is doing actually currently. You see. He's explaining. Anyway, putting in the mute, otherwise you can understand. Okay, so you can
Okay,
go
sir.
whenever any opportunity you can attend.
It is available in LinkedIn, sir. Your LinkedIn.
Yeah, my LinkedIn.
Yeah,
My
yeah.
LinkedIn, go
Okay.
to the post, go to the video, you can get it.
Sure, sir. Sure, sir. Sure, sir. Nice presentation, sir.
Thank you. Any
Sir,
participants?
ask questions, sir. Sir, am I audible, sir? Good evening.
Yeah, I'm audible.
Sir, is there any workshop available in this February month? Actually, I am also a research scholar doing Chennai only. So, is there any plans?
February. I think I'm opening all the personal data here itself. Okay, no problem.
Sorry.
February, just a minute. My students are planned. Just tell you.
On seeing all your facilities, I'm really very excited. If it is possible, we can come and we can have a look and we will have some ideas on it. Sir, actually, I'm just a fresher now. Just 6 months are over. So I think it's a lot of things are there. New things are upcoming. Is it possible so that we can see and?
So you see, February 23rd, you want to
Oh my
start.
God. Fine, sir. Oh, fine, sir. Okay.
23rd, but it's not a 6 days. I'm planning to wind up in 2 days only. But
Fine,
anyway,
sir.
in 2 days
Fine, sir.
we will cover some reasonable. So
Okay, okay. So we can apply it through your LinkedIn itself, sir. I will check it.
I will. What I told actually, you all supposed to be at LinkedIn. Okay, so I will post in the LinkedIn, so you can easily get a notification.
Thank you so much, sir. Thank you. Thank you so much. I will do it. Thank you.
Thank you, sir.
Or else I will do one thing. I will connect. I will get your all mail IDs from Madam. I will.
That will be so kind of you, sir. If it is possible, that will be so kind of you
I
for
will
us.
get mail ID and some data, means mobile number, and I can forward through the students. Okay.
We are looking forward, sir. Thank you. Thank you so much.
Thank you, ma'am. Any other questions, participants?
I think all are waiting for dinner. I'm also.
Sir, good afternoon,
Yes,
sir.
yes,
Yeah.
sir.
Sir, could you remember or not? I don't know, but I'm your old student as a part-time student in SRM
If
University.
you
Sir.
open your
In
camera,
part of-
then I will tell you whether I remember or not. I am opening it. You are remembering me, then you should open
Wait,
your.
sir. Wait, sir. Wait, sir.
Meanwhile, participants kindly fill the feedback form posted in the chat box.
Yeah, I
Sir,
remember. Yeah. Why not?
Damodaran batch.
Yeah. அதுக்காக நீங்க போட்டோ காமிங்கன்னா படினோட காமிக்கிறீங்க பரவாயில்ல. ஓகே. எங்க ஒர்க் பண்றீங்க? Where are you working now?
At present, I am a research in Sahasra University, sir, Tanjavur.
Very good. Okay.
6 months I have joined, sir.
And even I would like to say the participants, I have 4 vacancy now in my lab under the MIT program. All are more than 40,000 salary. That is also I am going to post LinkedIn within 2 days. Any research scholar who wanted to pursue research in full time, I think it's a right and good choice to apply. Yeah. Okay. So any other participants?
Any other questions, participants?
Chidambaram Mechanical. Please raise the hand, I guess. Chidambaram, PK, Mick. Okay, I think he's wrongly raised his hand.
Yes, sir.
But it was very good, sir. You are getting so many participants, 171. It's great.
Thank you, sir. Thank you, sir.
And I am also very happy to give
Okay, sir.
this much strength. Yeah, so many
Yes, sir.
presentation I used to give, but
Yes.
suddenly in the end, 15 people will be there. But now all are very enthusiastic participants. Okay, so any other
Okay,
questions?
thank you, sir. Any other questions? There are no questions, I think so. Shall we wind up the session, sir?
Yeah, sure.
Okay, sir. Okay. Participants kindly fill the feedback form posted in the chat box for the session 1. We will start sharply.
Sir, will we be getting the recording for this session, sir, actually?
Yes, ma'am. Yes, ma'am.
Thank you so
We will,
much. Thank you
we
so
will
much.
send it after completion of the all sessions, ma'am.
Okay, only all are done, we'll be
Sir,
getting.
the feedback link is not working, sir.
Now, okay, ma'am. All the participants are putting now, ma'am. You kindly check it, ma'am. So for many participants are put the feedback, ma'am. 40 up to 40 participants
Okay,
filled the
sir.
feedback.
Okay, sir. It's okay.
Okay,
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 sir.
ma'am.
Thank you, sir. Thank you.
Participants kindly fill the feedback form and their name should be in capital letters. Then will we
Hello.
we can be able to.
Sir, I'm not getting feedback form, sir.
Sir, we are posted in chat box, sir. Just check it, sir.
Or can you send it in the? Okay, I will see there.
Now also I'll put the feedback form.
Alternatively, can you have another arrangement?
What,
Let's
sir?
see. In fact, I am not able to see feedback form. That is why I am asking.
Sir, go to the chat box, sir. You can see the feedback link. That will be the link posted in chat box.
Okay,
Kindly
okay.
check it. It didn't copy. Just click the link, ma'am. It won't
Can you,
copy.
sir? Can you send it on my WhatsApp?
No, sir. It won't possible, sir.
Please do it,
Okay.
sir. I'm not getting this. That is why.
Madam, the feedback link won't add in WhatsApp, ma'am, because some faculty will not be attending, only putting the feedback. So the feedback link only shared in chat box. Thank you. We will start the next session shortly at 8 p.m. No problem, sir. From next feedback, you will fill in capital letters. Thank you. It's not points, ma'am. Just leave it. Hello, ma'am.
Hello?
Can we start the next session, ma'am? It's time.
Okay. Okay, start.
Mom Mageshwari, ma'am. Whether Ram Kumar sir joined?
Yeah, I'm here.
Okay, sir.
Good evening.
Good evening, sir.
Good evening.
Mom Mageshwari, ma'am. Sir, we will start in a minute, sir.
Yeah, sure. Just let me know. I'm just ready with my slides. Okay.
Good evening, everyone. Welcome back to the second session of ATAL FDP. In this session, Digital Twin for Real-Time Optimization will be handled by Mr. V. Ramkumar. It's my great pleasure to introduce our esteemed resource person for today's session. Mr. V. Ramkumar is a subject matter expert at Cylinder Electric, Bangalore, with 14 years of rich industry experience in the field of power system, reliability analysis, and industrial consulting. He holds a bachelor's degrees in electrical and electronic engineering from Anna University and an MBA in marketing and general management from Great Lakes Institute of Management, currently at Slender Electrics. Mr. Ram Kumar plays an key role in the Eco Consult portfolio where he leads, mentors, and supports a global consultation network of around 100 professionals. He has also served as a technical single point of contact for global consulting program catering to leading organizations such as J&J, Cobalt, sorry, Colgate, GSK, and Hellon. Prior to this, he has contributed significantly in reputed organizations like Quince Global Engineering, Reliance Industries Limited, and Ultratech Cements, handling critical responsibilities in power system reliability, arc flashing analysis, system integration, and large scale industrial operation. With his vast industrial exposure and practical expertises, today's session on digital twin of real-time optimization promises to be an insightful, engaging, and highly beneficial for all participants. On behalf of the organizing committee and all the participants of this ATAL FDP, I coordinately invite Mr. V. Ramkumar, subject matter expert, Slender Electric, Bangalore, to kindly take over the session and enlighten us with the expert talk on digital twin for real-time optimization. Sir, the visual stage is yours.
Thank you. Thanks for the opportunity to present to a community from where I grown up, and it has played a major role in my professional growth. So let me share my screen.
Yes, sir. You can share it.
Can you see my screen?
Yes, sir. Visible, sir.
Okay. So today I represent Schneider Electric to this forum. So you will see a lot of messaging.
Excuse me, sir.
Yeah.
Can you switch on the video, sir? Just for taking the screenshots.
Yeah, sure. Okay.
Okay, sir. Thank you.
Yeah, can you see my video?
Yes, sir.
Yeah, okay, sorry. I'm back here. So today I represent Schneider Electric. So you'll see a lot of messaging and information about Schneider Electric and what we do in the electrical world and power system world. Okay, so as a company, we believe in advancing energy technology for a sustainable future. So when I say sustainable future, we are looking at a future world where we are not reliant on any of the uh, uh, energy related or any manufacturing related chemicals which might result in global warming. Okay, so that's what this message says. So we see three mega trends today that are transforming our world. So previously it was four mega trends, including digital twin. So digital twin, we no longer see it as a mega trend. It's a new normal. Okay, so digital twin is not a mega trend anymore. So which I will explain, because today digital twin is conquering each and every corner of our world. Okay, so if I start with a new energy landscape, going forward, each and every consumer is very concerned about the energy he uses. Everybody wants to consume from solar, renewables. Okay, so the awareness is growing even within India. So the future is lower greenhouse gas emissions. Okay, so that is going to be the future. Digital and AI, it's already there, but still it is a mega trend because we have not settled down with an AI technology yet. So AI technology is going to evolve for next 10 years, which gives us a lot of opportunities. Okay, and who is at the back end of this AI growth is the electrical system. Okay, so it is going to act as a backbone of this electric AI growth. So without electrical, AI growth is impossible. Okay, and when I say electrical is going to be the backbone, because without energy and without the one creating the energy like renewables and replacing fossil fuels, it is going to be impossible to see the AI growth. Okay, and digital, it's already there. We are digitizing each and everything. Each and every part of the power system is today is being digitized. Okay, so these two things are very well known, and the next thing is a multipolar world. So multipolar world is not about technology, it is about politics. Okay, so today just an interview in Twitter by one of the presidents goes viral and it changes the markets upside down. Okay, so this multipolar world is inevitable. So the powerhouses are changing, new powerhouses are emerging, new markets are emerging. So today, not a single country can dominate the manufacturing politics. Not a single country can control the technology. So the technology is becoming more open. So it will result in a multipolar world where everybody coexists together. So these are all the three mega trends which we see that are transforming this world, which is going to come in the future. Okay, so each and every one of us in this call has a critical role to play here, because either I see a lot of researchers in the last call who are working for their research projects. If you understand this mega trends, maybe you can shape your research towards this mega trends. Okay, because aligning with the mega trends has been an important factor in success of each and every initiative. Okay, if you are not aligned with the world, you are lost. Okay, so the fourth mega trend which I removed, digital twin, which Schneider Electric was aligning for last 6 to 7 years. Today we see it as a new normal, because digital twin has become a business today, and we are accelerating. Okay, so if any one of you choose one of the mega trend as your research or as your scholarship, okay, whatever it is, then you might see a lot of success. Okay, so that's the idea of presenting the mega trends here. And then the next important thing is, like, we are in a new energy landscape. Okay, when I say we want to cut down the emissions, we want to reduce the dependence on fossil fuel, we want to increase the renewable, there is a new energy landscape. Okay, so the energy landscape is completely changing. Okay, so we must cut global emissions by 50% by 2030. Okay, the COP program has initiated 50% cut in global emissions by 2030. A lot of countries has committed to it. India has committed by 2070. We are a developing world, but at this rate of growth in investments coming in, we might see it faster. More renewables, 3 times more intermittent renewables between 2023 and 2030. Okay. You might have seen a lot of solar and renewable penetration already, but the penetration is not going to stop. It is going to grow further. Okay. And surging demand. 61% growth in global grid is projected from 2023 to 2040. Okay. Because the demand is growing up. AI is asking for a lot of power. Okay. So previously, maybe for a per square feet power consumption of AI was 120 kilowatt. Today, NVIDIA has come up with a chip which consumes 1 megawatt of power per square feet. So think of the scale. This demand is going to surge, and this is not going to stop until next 10 years. Okay, and increasing electrification. So when I say electrification, it is not only about electrifying all the nook and corner of the world. Electrification means we are replacing a lot of fossil and mechanical energy into electrical. So 90% of industrial process heat could be electrified with technology being developed today. So if you take the food industries, if you take any chemical industries, they are using fuel heaters or gas heaters. Today, most of these gas heaters are replaced by electrical heaters. Okay, and this change is already there. We are doing these projects for last 3 years. Once there was sanctions on Russia and sanctions on purchasing of natural gas and other things, this electrification story has started. Everybody in Europe saw gas as a non-reliable resource, and they started to shift to electrical heaters. Okay, so when you think a process, maybe a mini boiler is being electrified with electrical heaters, you think of the energy demand. Energy demand is going to grow up. Okay. Then the last important thing, technology disruption. So we have all seen alternating current as a normal, but it is changing. 80% of energy consumed at home by 2030 will be direct current. I know this will be a surprise, but this is going to be a new normal. I think everybody is sitting with your laptops or mobile phones somewhere. What is the power your laptop consumes or the processor needs? It's direct current. So just to feed the direct current to your processor, how many conversions you are facing? So right from your home, you have your alternating current coming down to your UPS, which is converting this AC into DC, storing in a battery. And then you have an inverter, DC to AC. Okay. And then it comes to your laptop charger, which is again converting its AC into DC. So we are seeing already a 3-stage of conversion here. What is the efficiency of each stage of conversion? How much power we are losing? Okay, maybe with power electronics, I think some professors are already here who are trying to achieve an efficient conversion systems. Okay, even after that, when you are able to do a distribution in direct current right from your solar to your microprocessor, why do you need these many stages of conversion? If we simplify this stream, we will save a lot of energy and we will save a lot of money. There is already a drive happening in some parts of Europe. They are converting their home into direct current. So DC become obsolete when Nikola Tesla taken over. But DC is coming back now with renewables. Okay. So this is what we see as a technology disruption, which is going to happen in the near future. And we are already investing in direct current technologies. Okay. So we are investing in direct current distribution. So direct current distribution might be the new normal. So this is the new energy landscape. Okay, so I stopped here. I just wanted to see if there are any questions. Okay, because these are all like debatable topics. So if there are any questions.
Participants, any questions so far?
No, good.
No, sir. You can carry on, sir.
Yeah, thank you. So in this energy landscape, though it is challenging, it is providing us with a lot of opportunities. And this opportunity is coming in various forms. And most of this opportunity is coming within the electrification topic. So we need our grid to be more robust. We need our distribution systems to be revamped. We need a lot of technological changes to come in. We need a lot of artificial intelligence to help us to create this new energy landscape. Okay, because today it's a big challenge for power system experts like us to meet the demands of customers. We are struggling a lot with the change or the rapid pace the change is happening. Okay, it's very fast and we are not able to cope up with this. Digital and AI is everywhere. Demand for data centers, 4x growth in global demand. If you just listen to yesterday's budget, there is a tax exemption up to 2047. So right from today morning, within our organization, we are having this as a big discussion. Is India is going to be the next data center hub? Might be. Because businesses go where there is a tax benefit. And today we are giving a complete tax benefit and for 20 years for data centers. So India might be the future data center hub. Okay. Explosive IoT growth, IoT devices, 50 billion IoT devices are going to come within 2030. Because with all the digitization, all the integration, it is not possible without IoT devices. Okay. And robotics, 6x growth is expected because the dependency on human workforce is reducing, or it might, or there is another perspective. In order for a rapid production and rapid manufacturing, we are going to rely on robotics a lot. Okay. In the rise of agentic AI. So I need not comment on this today. Everybody in our hand, we have Gemini and Copilot. So even ChatGPT started it, Gemini and Copilot taken over that. Okay, so it is going to, I would say, for example, it took, I think the mobile phone, it was introduced in 1996. It took at least 14 to 15 years to reach every household, and 17 to 18 years to reach to every hands. But today, AI has reached everyone within less than 2 years. Okay, so the growth is exponential. And smart manufacturing, everybody wants to invest on smart manufacturing. Everybody wants to invest on AI, because when you have an inefficient manufacturing or a production line, you cannot be competitive in the market. You will lose your price advantage. You will lose your margin. So each and every customer we speak, they are asking for, do you have an AI integration? Okay. So now this is starting at big players. Okay. Today it's like the persons who have a $100 billion business, or even $100 billion is a big number today, like $1 billion, who has a revenue of $1 billion, they are ready to invest in AI. Tomorrow it will be like the zeros will reduce. Tomorrow everybody will be investing in AI. Okay, so the demand is there. And when I say about a multipolar world, supply chains are re-engineered. 97%, okay, of the supply chain leaders, they want to rearrange their supply chain so that they stay close to their demand center. When I say demand center, India is the biggest demand center. We have a lot of population who can consume. So everybody will have their manufacturing, everybody will have their supply chains structure towards India and China. Okay, because that is where the consumption is going to be. Okay, so this will affect the global trade by 18%. Okay, so when we localize and reorganize the supply chain, there will be a reduction in global trade. There will be a reduction in dependency on other economies. Okay, workforce shortage, and this is another topic. So today, just to be in a real terms, we are facing a bigger scarcity of electrical and mechanical engineers, around 7 to 15 years of experience, just because we lost them to IT. Okay, and we are able to find less than 5 years very easily, but less than 5 years are somebody who we might not expect a complete turnover. So the deliverable workforce is today it doesn't exist, and there is a huge demand in countries like European and Middle East countries. There is a huge demand for engineering workforce because there are other factors which are affecting the workforce shortage. Okay, the demand in IT is now translating to engineering sectors. That's the change which we are seeing post-COVID. The complexity is real. There is a lot of complexity, but so is the opportunity. We have opportunities in each and every corner. Okay, we have opportunity in buildings and homes. Today we are seeing smart homes. Everybody wants to use their home electricity with the help of Alexa and Google Assistant. Okay, smart homes are coming up. Data centers, it's another buzzing topic. Industries, okay, industries, they want to be intelligent, autonomous, and and they want to be agile. When I say agile, they want to adapt to changes instantly. Okay, and infrastructure, when I come to infrastructure, this is another change which is going to come with respect to mobility, interconnected infrastructure. Okay, so the mobility is going to get simpler in future. Okay, and when I say sustainable cities, it doesn't come by only renewable. We need to have more electrical vehicles. We need to have more electrical transportation with the help of metros, electric trains, high-speed trains, which make it simpler for the common man to commute. Okay, otherwise we are not going to survive, because infrastructure is another thing where the opportunities is coming up. So electricity is at the center of all these transformations. Okay, right from renewables, microgrid, autonomous power generation, prosumer. So when I say prosumer, it's a new word which we have coined a couple of years back. Today there are no consumers. Consumers are reducing. Consumers of electricity is reducing. So why do I say? Because each and every homes now they have a solar. They also produce and they also consume. So the complexity is going to increase. Okay. So today, in the past, we were just worrying about the power and grid. Okay, how to control them. But today we need to worry about how to control this prosumer. Okay, and maybe controlling power and grid was very simple. Okay, we might have controlled only in the power station. Now these prosumers are everywhere, in every corner. Controlling them is going to be very complex. The next thing is EV at scale. Okay, today EV has not scaled in India, but definitely it is going to scale after the tax exemptions by the recent budget. There is no tax for lithium battery import, so EV is definitely going to be cheaper, and we are going to get a lot of EVs on road. The next thing is storage. So battery energy storage, it has been a expensive topic in the past, but there are technologies or researchers coming up to maximize the utilization of battery at the scale of grid. Okay, but still we have a long way to go in research around battery energy storage. We have a very long way because the cost of ownership or cost of maintaining the battery infrastructure is getting very expensive. Okay, so nobody is interested to invest. But if we get some technology or some research which comes up with a more efficient battery, at grid scale, this is also going to get scale up. Okay, because without this storage and renewables, renewable, it's a known thing that it doesn't have inertia. So with the combination of an efficient storage and renewable, we might be able to replace this fossil-based power generation. Okay, so the opportunities are coming in this direction in the current market. Okay. Now, what is important? Energy and industrial intelligence. Okay. So now when I say this energy and industrial intelligence, and I'm speaking about how to control them. Okay. Now, today we are speaking about an efficient world where we want to consume a better energy and an energy which can be more efficient. When I say more efficient, the losses are minimum. Okay, and most of you understand the power system as a whole. If you have a proper planning, okay, if you are able to plan, what does this residential human need for next 30 days, we can plan this infrastructure better. Okay, so this intelligence is going to rule the future. Okay, even you might say, okay, today everything is everything connected? Yes, slowly everything is getting connected. Okay, I'll show you in subsequent slides how everything is getting connected today. Okay, so when everything is able to be connected with electricity, with the same electricity, we can also control them. Okay, so to control that, we need intelligence, and this intelligence is going to come in the form of data we are going to collect from each and every character in this circle. Okay, and this data is very crucial. Okay, and without this data, it is impossible to control that big network. Okay, because in the future, it is not going to be frequency, or it is not going to be the voltage which is going to control this. Okay, it is the data which is going to control the operation of power system. Okay, so this is going to be very important. Okay, so we have come up with something which is called as a data cube. So this data cube is nothing but a data ecosystem which can deliver industrial intelligence. Okay, so we call something called as a data federation, where we onboard the field data and the ecosystem data, we get the operational data, and then we try to optimize with the help of device, edge control, and cloud. Okay, so what can enable this? Domain expertise and ecosystem. So when I say domain expertise, we need more expertise to handle this growth. We need more expertise to manage this intelligence. Okay, and today we are investing a lot on this expertise also. Okay, how can we organize this data, and how can we acquire this data? Okay, right from a different customer persona, like building data center industry and infrastructure. Okay, and it will be enabled by digital twin. So digital twin across life cycle. Okay, so a digital twin is nothing but, I see it was also a discussion topic in the last presentation. So where the presenter mentioned about digital twin. Digital twin is nothing but a real life replica. Okay, so if you do not know the word, maybe if you're not updated, digital twin is the new normal. Okay, so for example, if you just imagine about an engine or a motor. Okay, creating an exact replica of a motor in a digital pointer, in a digital world or a software world, is a digital twin. Is it new for us? No, it is not new. We just evolved with what we know. AutoCAD was a digital twin of the past. An AutoCAD drawing was a digital twin of the past. A power system model is also a digital twin of the past. Today, an AutoCAD has evolved into a power system model. A power system model has evolved into a digital twin. Okay, and today the basis of this digital twin starts from a structure like AutoCAD, where you draw everything, and then a power system model, where you create all your power system analysis, load flow, short circuit, okay, all this analysis. And then you collect the data from the real world with the help of the communication. And with this data, you make decision with the help of AI applications. Okay. Now, AI applications is yet to come. Okay. But we are investing on the data cube because data is very important here. And this data cube is going to help all the dimensions. So the dimensions of control is yet to come. Okay. Now let me introduce you to digital twin. Okay. So what is an electrical digital twin? And this electrical digital twin is going to transform a lot of things in the future. Okay. Because as I said, electricity is going to be the center of transformation. It is going to be the backbone of future. Electrical digital twin has a big role to play. Okay. So this is a traditional approach. 15 years back, if you want to go somewhere, you might have carried some physical maps, right? So electrical distribution was, we were carrying single line diagrams, maybe generated by a draftsman or a printout from an AutoCAD. We were carrying single line diagrams, okay? Today, Google Maps. Google Maps is nothing but a digital twin of the map or digital twin of the globe, okay? There was something called as a Google Earth. While I was in my college, we used to use a lot of Google Earth. Google Earth is not existing today. Google Earth was first kind of digital twin. Okay, so Google Map is kind of a digital twin. So with Google Map, what you do, you just put your destination, and with your destination, you understand how long it might take for you to reach there, and you also determine what is the best route you can take. What is the best route you can take to reach your destination? Okay, and maybe in the future with your EV coming in, you might also determine if you have a better digital twin of your EV. You might be able to determine is it possible for you to reach that location with the current battery percentage. Okay, that is going to be the evaluation. Okay, so this similarly we are creating it with ETAP. Okay, so you see the map, it is your SLD, okay, and you're creating and configuring your electrical system here. And when you create and configure your electrical system, you are ready for your engineering analysis, okay, and power system operation. So now you start navigating. So when you start navigating, you try to know what is your traffic here. Similarly, when you start operating or you are simulating an operation here, okay, you do a full network analysis and you do your, what is your load flow, what is your short circuit, which transformer will become overloaded, okay, and what is the flexibility I have here. So this is a simulation what we do, okay. It is not a real world measurement. It is not based on any real world data. Whatever you do is within your computer, you simulate everything. You don't use real world data. Okay. Now we are going to an extra mile, okay, where you also connect your real world measurements to the ETAP. Okay. When you connect your real world measurements with the help of the real-time data from smart meters or eSCADA, you quickly determine the root cause of outages and disturbances using forensic analysis solutions. So with this, there comes a flexibility for the user. He can operate with the design knowledge, or he can design with the operation knowledge, vice versa. He can prevent a system interruption, and he can accelerate the operator training. Now, what is going to come in the future? The operator will be replaced. We will have AI applications running this entire show. Okay, so these AI applications, today the biggest challenge we have is the lack of disconnected data. Okay, so now let's, if you just imagine the life cycle of a transformer is like 50 to 60 years. Okay, the transformer might fail after 60 years. Okay. So when do I say that the transformer might fail? So I need 60 years of data. So I am just started to connect my infrastructure right from 2015 or 2018. How do I get this 60 years of data? It's not possible today. So what we are trying to do, we are going to rely on the data cube. So the data cube is nothing but it will collect the life cycle information of all the transformers around the world. It will create a fingerprint saying that a 37-year-old transformer will look like this. A 50-year-old transformer will look like this. A 60-year-old transformer will look like this. So we are creating fingerprints. And with this fingerprint, we are trying to train the engine which is going to make the decisions. Okay. So this is a concept today. It has not been tested. We need a lot of research to make this possible. And even the mathematical models which are available in ETAP or any other platform, it is not so accurate enough to predict a real world situation. Okay, so the mathematical model, whatever we have within ETAP, it is based on the machine design. Okay, all the formulas we have. It never takes into account of the environmental data. For example, if you see in a Google map, it takes the real world data of traffic. It also informs you of any blockages here. Okay, such things doesn't exist. Now, for example, just for a motor, if you take a motor, you just estimate the full load current. Okay, it might, like for example, a 15 ampere motor. And you set a overload setting for a 15 ampere motor at 15 amps. Okay, just the simulation we do here. But there are other practical things like environmental factors like temperature, dust, the last maintenance or the operating conditions of the motor, which are not accounted inside our mathematical model. So it's the biggest drawback which we are facing, and we are trying to improve the mathematical models available. And we are also reaching out the industry and institutional researchers who are already working on this to improve the mathematical models we have today. Okay, so such opportunities are coming up for, like it is like we are not inventing something new. We are reinventing things for the world that is changing. Okay, so maybe like to be practical, it might be very difficult to find a research topic within electrical and others, electrical and mechanical, because a lot of things has been done for last 100 years. Okay, so the real world challenges are prompting new innovations. Okay, so if we improve whatever we have today and we make it as a better for the world that is coming in the future, it is going to be a real success. Okay, so that is what this digital twin is trying to do. Digital twin, today we are just creating a skeleton. So when we create the skeleton and when this mathematical model, this AI application, everything kicks in, this is going to operate on its own. Okay, but it's going to take at least 10 to 15 years to reach each and every corner. I am very pessimistic today at the rate of change what is happening around the world. AI can reach in 3 years, maybe digital twin also will reach in 3 years to all the corners of the world. Okay, any question?
So sorry, I have a question, shall I?
Yeah.
So actually, you were explaining.
Yeah, sure.
You were explaining about the transformer. I could get something out of it, like the age of a transformer, something like that. So, what will be the practical application in finding it? In actually, can you tell me some layman application for it? I couldn't get it. You people are telling far away applications and all. As a
So the
what will be the
practical
practical
application
thing to find the age and all? Yeah, with respect to Chennai or a particular area, we are having a lot of transformers, as you told. In finding the age of each and everything, what would be the practical thing? I can't imagine that. Can you just elaborate on that, please?
So the practical application, what I could, we have seen this in the past. For example, we went to a facility in Sweden, okay, where we saw a customer having a transformer of 50 years of age. He had no money to invest, but he says, "Am I nearing end of my life for my transformer?" This was the question he had. And he said, can you help me to estimate the residual life of this transformer? Okay, how do we estimate? Because our models, it just speaks about current and voltage. It never include an aging factor, aging of insulation. It did not include something kind of what kind of climatic impact the particular transformer might face. We never considered. Okay. Similarly, in Chennai, okay, you install two transformers inside a building, well ventilated, another transformer outside. You have a same mathematical model for both transformers. A transformer within a well ventilated and a well preserved environment may survive for 60 years, but the transformer which is outside, it might not survive 60 years. So we are missing a real world simulation. That is the biggest challenge for a digital twin. Okay, and the operating parameters are completely different. It might not be much different for a very small transformer like 2 MVA or 10 MVA. So when you have like 53 MVA or 110 MVA or even higher voltage transformers, the operating condition and also the environmental condition plays a major role. Okay, which we have completely ignored in our past mathematical models, or the mathematical models what we have within our simulators we completely ignored, which today we are trying to bring everything together.
Okay, sir. Fine, sir.
Okay, so it is it might not be visible in your for example mathematical models, or we did not consider, but today it is needed. When you want your digital twin to operate, when you want your AI application to supervise, we need this. Without this, it is not going to be possible. Okay. Without this, if this is not going to be possible, if we cannot replicate the same real world situation inside a MATLAB or a simulator, maybe we might not achieve the concept of AI governing the entire power system. No, we might not. Okay, but things are changing. Okay, not in the best way within the electrical infrastructure, but outside the electrical infrastructure, things are changing very fast. But electrical infrastructure will also come to this space in the near future with the digital twin, all these integrations coming into picture. Okay, so, and thanks to the workforce around electrical engineering we had in the recent past, we were able to operate such a big system. But in the future, with the reducing workforce in electrical field, it's not going to be possible. So everybody is looking for this automation. Everybody want to invest on the predictive technologies in electrical industry. They want to know when I need to replace my transformer, when I need to do a maintenance for my transformer, and why should I do every year? Why can't I wait for a failure to trigger in? Okay, for example, today I need to say this is only going to fail. I'm accelerating the digital twin change. Okay, so it started around 2015, which we called as a perception AI, computer vision and speech recognition. That's perception. And then generative AI last 5 years, 2025. So like translating between modalities, text to image, text recognition, speech recognition, generating automatic content. Okay, and then agentic AI, which came in last 2 to 3 years. AI with agency capable of perceiving, reasoning, planning, and acting using tools. The classic example is ChatGPT. Okay, physical AI. This is what I was speaking about. The next wave. AI that understands the physical world, enabling robotics. So in their language, they say enabling robotics. In our language, enabling operating flexibilities. Okay. The AI that understands physical world is going to be the next generation. Okay, we need to understand how the equipments are installed, how they are operating, what is the stress they are facing, what is the impact that they are facing because of the environment, what is the impact that they are facing because of the loading, how much amperes they are being loaded, what are all the chemical and property changes that are happening within the equipment itself. That is something, the next wave that is going to come in. Okay, so if you are able to get this into picture, then the digital twin is going to accelerate. So I want to present you an interesting speech. Okay, I think nobody I think everybody would have recognized this person. Okay, he is a famous CEO of NVIDIA. I just want you to see this video. We will take some pointers from this video and we will structure our discussion. Okay. Are you able to hear the voice? I'm not sure. Just a minute. I'll stop present. Okay. Also share the tab audio. Also share all audio outputs. Okay. Maybe now we will.
When the technology is moving the.
Were you able to hear the audio?
Yes, sir, we can.
Yeah, okay.
When the technology is moving this fast, and because the workload is so intense, and you're building these things, they're factories. We really like you to invest in the right versions. Okay, just to put it in perspective, this is what a 100 megawatt factory looks like. There's a 100 megawatt factory. You have, based on hoppers, you have 45,000 dies, 1,400 racks, and it produces 300 million tokens per second. Okay, and then this is what it looks like with Blackwell. You have 86. Yeah, I know. That doesn't.
Sorry, I just wanted to pause. I'll stay in the screen.
When the technical sales guys going.
Okay. Can you see here? 100 megawatt AI factory. In the past, it would have had 1,400 racks. Now it reduces to 600 racks. And then a data center productivity of 300 megabytes has become 12,000 megabytes. So what does this mean? If a rack is nothing but less than 1 square meter of area. Okay, so 100 megawatt was consumed at 1,400 square meter of area in the past. It is going to be consumed in 600 square meter of area. And it will process more data and 40x more to come. What does it mean? The requirement of energy. Okay, today, for example, if you have a 1,000 square meter infrastructure, today they are consuming around, roughly around 800, like 80 or 75 megawatt. Tomorrow, for the same area, they will consume around 200 megawatt, not 200 megawatt, more than that. Okay, so the energy consumption is going to grow up with AI.
Okay, so we're not trying to sell you less. Okay, our sales guys are going, Jensen, you're selling them less.
Okay.
This is better. Okay, and so anyways, the more you buy, the more you save. It's even better than that. Now, the more you buy, the more you make, you know? And so anyhow, remember, everything is in the context, everything is now in the context of AI factories. And although we talk about the chips, you always start from scale up. We talk about the chips, but you always start from scale up, the full scale up. What can you scale up to the maximum? I want to show you now what an AI factory looks like, but AI factories are so complicated. I just gave you an example of one rack. It has 600,000 parts. You know, it's 3,000 pounds. Now, you've got to take that and connect it with a whole bunch of others. And so we are starting to build what we call the digital twin of every data center. Before you build a data center, you have to build a digital twin. Let's take a look at this. This is just incredibly beautiful.
Okay. So what does he say? Before you build a data center, you build a digital twin. So without digital twin, in coming days, nothing is going to be built. Previously, we were speaking about drawings. We will be speaking about design basis or design concepts. From today onwards, it's digital twin. Without digital twin, nobody is going to build anything. That is the new normal. NVIDIA has kickstarted it. Everybody is rapidly adopting it. Okay. Now, all the investments coming in for new projects, anything that is new, everybody will ask for a digital twin. And this adoption, maybe I said 10 to 15 years, it might come very quicker. Okay, let's see what is the digital twin he is speaking about. Sorry.
When the technology is moving, like of 1 round. Let's take a look at this. This is just incredibly beautiful. The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers, from suppliers, architects, contractors, and engineers, to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The NVIDIA Omniverse blueprint for AI factory digital twins enables us to design and optimize these AI factories long before physical construction starts. Here, NVIDIA engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest NVIDIA DGX SuperPods and advanced power and cooling systems from Vertiv and Schneider Electric, and optimized topology from NVIDIA Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. NVIDIA uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability. Real-time simulation lets us iterate and run large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory.
Okay. Sorry. So this is what the digital twin it is. At Schneider Electric, we have been working on digital twin for last 5 to 6 years, how to replicate the real world installations or real world products what we supply. Okay. Even though we have a lot of improvements to make, the world is not going to wait for us. improvements will come, but the adoption is going at a rapid scale. Okay, so now let's see. This is a reference design released by NVIDIA. Schneider Electric, there was a mention about Schneider Electric that we have a digital twin that has been released. I will showcase you the digital twin, what we have created for NVIDIA. So this digital twin is completely built with ETAP, Electrical Transient Analysis Program, which traditionally it has been used for power system analysis. Okay, and today the power system analysis software is turning out to be a digital twin backbone of all power systems. Okay, and the basis of this is pure power system analysis, nothing more than that. Sorry, I just wanted to pass. I will stay like this. So this is a showcase of how a data center with a traditional GPU can migrate to an NVIDIA AI GPU. Okay, and how an electrical digital twin can fast track the decisions and how we can fastly design it. Okay, so this was a reference design we released along with NVIDIA to build up their GPU in a customer facility. So it is a capability of ETAP what we are demonstrating from here on. Okay, so that is how easily a digital twin can help accelerate the changes. Okay, for example, if there is a data center owner who wants to migrate to NVIDIA GPUs, okay, how fastly he can identify its investments, how fastly he can get his investments streamlined is something we are looking here. Okay, so like
sorry
he
to
said,
interrupt, sir.
yeah.
Somebody is speaking. Kindly mute. Sorry. Any person from PSNA kindly mute somebody is making some background.
பெங்களூர் ஸ்னைடர்ல இருக்கா நிகோட்டியா போட்டேக்கா தனி ஊதுமா தனியா
Oh my
Shit,
god.
I'm not able to find it. Yeah, that's okay. Is it good now?
Yes,
Yes,
sir.
sir.
Thank you. Thank
Yeah,
you.
okay, no problem. So, so far it's a cap showcasing the capability of a digital twin. Okay. Going
Hello,
forward,
sir.
yeah,
Good evening.
good evening.
Yeah, I could understand the presentation, but E-type normally we are doing for all the power system analysis
Yes.
problems, but
Yeah.
I think you have shown the same thing. What is the point of
Yes.
digital twin technology in this?
I'm coming in the next steps.
Okay, thank you.
I'm coming in the next steps. Okay. So, because here I'm just constructing a story like how from starting an installation, going up to operation, and how ETAP or a digital twin can help in operations. Okay. So this is how now I am showing, like, if you want to make some changes, how it is going to be very easy. Okay. So in the next thing, I'm coming to this. Okay. So this is what today we call it as digital engineering. Okay. So digital engineering is something you create instead of your CAD drawings. From your CAD drawings, you create a power system model, then your digital SLD, and then you create a 3D model. You update the load list and you structure everything. Then you do all your lightning, HVAC, substation, and civil. From this, you will do all the detailed design, O&M support, remote engineering, whatever that needs to be done for engineering of a new facility. Okay. So this is for a new facility. And then your power system model, if you connect with SCADA architecture or IO, simplifying the networking, with specifying the networking, you connect all your meters, the power system model will help you to make decisions. Okay. To be frank, the decisions made today are still manual. ETAP is just assisting you as an interface, but in the future, it is going to make decisions on its own with the help of the data cube or the artificial intelligence. So whatever today we are creating, it is the base. Now we also have a use case for that. I'll first showcase how a 3D modeling and a detail engineering happens between Aviva and ATAL. Okay.
This video will explain the digital single line diagram concept. The electrical engineering is in progress, and a complete ETAP electrical digital twin is available. Power system engineering studies, like load flow, can be run to validate and commit changes to the design. The ETAP model is automatically imported into Aviva Engineering via a native import function. We are now in Aviva Engineering. Once the import process is complete, a comparison table is available to improve the efficiency and check data integrity before validating the Aviva database update. The single line diagram is created in Aviva Engineering utilizing the topology imported from ETAP. This is a key deliverable in the design lifecycle. We extend the data consistency to the 3D engineering. The 3D plant model created in Aviva E3D is interconnected with the Aviva Engineering database. At this stage, we ensure data consistency between ETAP, Aviva Engineering, and Aviva E3D. Continue through the engineering process by proceeding to the cable routing in Aviva E3D. Let's focus on two cables. First step, Aviva E3D and Aviva Engineering global databases need to be synchronized, with all data sourced from ETAP as cross-sections are available. The exact length will be automatically computed with the auto-routing module available in Aviva E3D. This module is based on embedded design rules, which select the best cable trays and arrangement. Now the two cables are routed within the layout, and their total lengths are available in Aviva E3D. Let's now update the Aviva Engineering database with the new cable data and then export the database back into ETAP. Compare and update tables are available to easily perform the data synchronization. Cable length is now updated, and the 3D view is still available in Aviva Engineering to check cable routing.
So if I see this, sorry, I skipped to the next screen. So if you see here, as you updated the location in your 3D model, if you have just changed the location of your particular device in the 3D model, your cable length has automatically changed. And this cable length data is automatically backfed into ETAP. So this real-time exchange of data is called as a digital twin during design. Okay, so whenever there is a change that is happening in a 3D model, it will automatically get updated into ETAP, and ETAP will give its own results. This is what we do in an design stage. Okay, so this is an example of how to do this integration between softwares, a mechanical software and electrical software. Okay, like Aviva is for a process design and a process layout. Similarly, ETAP is for electrical. Okay, this is in case of a process industry. Now, what we saw in this NVIDIA case, it was an integration between ETAP as a electrical digital twin, and we also have something called as a cooling digital twin. So the cooling digital twin is nothing but a mechanical digital twin. Okay. Now these two digital twins are starting to communicate with each other, and which helps us to make decisions faster. So this is completely during the design stage. Now, as your question, I'm coming to the operational stage. This is what happens in an operation stage. Okay, so a digital twin starts from the design. When you design a project, we start a digital twin. We can also create a digital twin for an existing factory or an existing manufacturing, which we are doing extensively today. A lot of customers who have a lot of big factories, big industries, they want to create a digital twin today. Even though their industry is 30 years old, they want to have a digital twin so that they can plan their decisions. Okay, this is how now an integration of ETAP digital twin with each and every layer can help you to make decisions. Okay, let me take my pointer out. So this is your base where you do your design and planning study. You build your SLD, equipment management. You do all your configurations. Okay, and then the next level where you do your detail engineering, where detailed power system studies and analysis, and then you update the ETAP model, you change whatever, make all the changes. And then you also do something called as information management and record management, where you create all the database for the future. Okay, and then next is the operational layer, where comes the SCADA. Okay, when the SCADA comes in, it is something called a TDMS. Okay, so you have an intelligent GIS model with network topology, which has all your network. Then this network is nothing but your single line diagram from your ETAP, which will be converted into a GIS model. And then connection to field devices over IoT. When I say connection to field devices, all your circuit breakers, all your motors, all your electrical or non-electrical devices will be connected via IoT to this TDMS. Okay, and the asset and model change management, power workflow, these are all something, for example, if there is some changes coming in, how this workflow is handled. Okay, then there is a third layer where the enterprise applications come in. Okay, so where you have your dashboard, okay, and where you have your web-based power analytics, which is AI-based, and then where you have your web-based email notifier, you have your energy accounting, KPI dashboard, and web-based HMI client. So this is a power digital twin. Okay, you have your model interacting with your field data through various control network, advanced applications, and communication service. Okay, which is nothing but your SCADA. When you connect both, you get your power digital twin. Okay, now when this power digital twin starts interacting with other digital twins, like your mechanical digital twin or your EV digital twin, then the control or the AI prediction or estimation happens. Okay, But there are a lot of scope within this power digital twin also for optimized operation. Our network topology itself very complex that you need to make a lot of decisions to determine the best case scenario of operation. Okay, starting from arc flash, short circuit capability, load flow. There are a lot of decisions to make at the network layer itself, which will be made here, web-based power analytics. But this as a digital twin can also communicate with other layers. Okay, which comes in the next video, which I'm going to explain. Okay, so today it's still manual because the interface within other digital twin, it's not realistic today, but there are some integrations going on with the help of Aviva and ETAP. Okay, I'm not sure why I'm not able to play this. Maybe I'll do a slideshow. Sorry, there is something wrong with this video. I'll just stop sharing.
Slide not visible, sir.
Yeah, just a minute. I'm just sharing the other the video. I'm not able to play the video.
Okay, sir.
Yeah. Just a minute. I'm just trying to play here. So
This video will explain the digital single line diagram concept.
Maybe it's the same video. Let me go back. Okay. I'm just sharing my screen again.
Okay, sir.
Yeah. Yeah.
Sir, voice is not coming, sir.
Okay.
Can you share the link, sir?
Yeah, just a minute. I will just play it. Yeah.
ETAP digital twin with real-time data in 60 seconds.
Unplanned downtime has huge financial consequences, but did you know that 40% of unexpected shutdowns are caused by operator error? And the more complex the electrical network, the bigger the chance of an accidental power outage. The good news, there's a way to reduce the risk and empower operators and power system engineers to make better decisions with ETAP Predictive Simulation Engine. When connected to EcoStruxure Power Management software, the simulation engine uses real-time data to help power system engineers develop standard operating procedures, train operators, plan expansions, and validate contingency plans. It will also notify an operator of any risks associated with a control command before the operator executes the command on the live system, helping ensure a wrong decision is not made. Think of it as a digital twin assistant for safer, more reliable, and efficient operations. That's ETAP Digital Twin with real-time data in 60 seconds.
So now I just have one question because I see I just have one question, okay, to all the researchers and professors over here. What do you think this digital twin is going to change in the future? Okay. Even in today's landscape, we are seeing a lot of change. The customers, they don't want to have, bottlenecks in their operations. Okay. What is the one change which you think you will see with the adoption of digital twin? Because today it's just a power system, not today. In the past, it was just a power system analysis tool. And this tool is evolving into something called as a digital twin. Do you think it is right or we are missing out something? I'm just talking about the power digital twin because nothing beyond that. Any thoughts? Or should I continue and close? No? Okay. So, I'll share my screen again. So this is the architecture. This is the architecture of an ETAP electrical digital twin. Okay. Now ETAP as a center of it, which collects all the data from RTUs and everything. If you can see here, wherever there is ETAP, there is a node connected to this. Okay. And ETAP plays a vital role in governing the power system itself, because within the power system, at the end of the day, it's nothing but the parameters that govern the power system operations can be simulated within ETAP, nothing outside that. Something like load flow, power system, grid code, grid modeling, load sharing, everything can be simulated with ETAP. Now with the data, what we are going to acquire from each and every node, it will help us to make faster decisions. Okay. Now there are some expansions that are needed from the perspective of renewables and EV, which are coming in, where we are trying to gather the real world data. So real world data, like for example, wind speed, forecast, or the amount of sunlight, what we can see in the solar panels. So those real world data gathering is something which we are working on today, and ETAP is heavily investing on it. Okay. So this might be one of your research topics if you are looking for. Okay. Now, current challenges hindering digital twin adoption: data integration complexity, because the integration of smart meters in the public or the government grid infrastructure is very less today. It might be at the level of discoms or power distribution substations, but into the end consumer level, it is very limited, and which is a challenging to have a digital twin of the entire grid itself. Okay, because the grid digital twin or a microgrid controller communication is very essential here to have a complete control by a digital twin. Interoperability issues. So digital twin platforms struggle to interface with existing IT, OT, and IoT systems. So even within our industry, electrical industry, each and every OEM or a software company, we have our own digital twin. Okay, we have our own solution. And so interoperability means like communicating with ourselves. It is a challenge today. We have not reached to an agreement. Modeling and simulation complexity. I think this I spoke already. High fidelity models are needed today. We need high fidelity models which can resemble a real world equipment, okay, or a real world operation, or which can help us to capture the dynamic grid behavior, including renewables and electrical vehicles. Okay, I think electrical vehicles, it's already there. Each and every car today, it's connected with GPS, and we can also have data acquisition from electrical vehicles. So definitely, it's not going to be a challenge because there is another set of industry working heavily on electrical vehicles. They want to create a connectable car. They want to create an automated driver system. They want to have their own digital twin. Okay, that is going to be very easy. But what's challenging is within our electrical infrastructure, that is the renewables. Okay, cybersecurity risks. Yes, obviously, when you have a network that is connecting everything, the data theft is going to be very difficult. Okay. Now, what we are going to do, we are going to pre-train our digital twin with the intelligence we have or the kind of knowledge base we have, and then enrich with our expertise. And then with the help of the data, what we collect, we post-train, and then we adapt and optimize. This is what the data cube is going to do. For that, we need to have the adoption of digital twin at a complete scale. Otherwise, it is not going to be possible. Okay. And this agentic workflows, this agentic AI workflows will come into picture only if you have a digital twin that can interact with other platforms. Okay. Unless otherwise you create a lot of AI applications, you create a lot of agentic AI, implementing them and getting the real results is going to be a challenge, because the agentic AI or AI supervisory control, it is going to come only if you have your digital twin ready. Okay. So for this, we are creating something called as a unified data federation AI, and then unified user experience, and also a software federation as a base. Okay. So we have ETAP, Aviva, and EcoStruxure for power, Plan-On for building, and RIB for reliability studies. Okay. So we are even making this open to a wider community like you and also the student community, where you can access our APIs, okay, and you can also use our data into advisors or in your research, okay, via external interfaces. So the future is going to be open source in electrical power system, okay. All the data modeling and everything is going to be available for each and every user in the network, okay. So bringing together all the expertise we have around the world, we believe that we can create an open ecosystem which can coexist with collective intelligence, okay. So if you are planning for some research or some software development or a model development, or if you want to access some data set, or if you want to participate in our expert-led technical forums, you can reach to exchange@se.com, exchange.se.com. I have seen some of the researchers in a different country, they post their research around renewable energy management or renewable forecasting, and today they are a subsidiary company of Schneider. Okay, they have been bootstrapped as a subsidiary company of Schneider. Okay, so there are a lot of entrepreneurial opportunities and research opportunities available with the help of exchange@se.com. So we believe in an open community where we co-develop everything. So if your research is aligned with one of our ambitions, or if your research is aligned with one of the transformations that is happening around the world, it will be recognized, or it will be given it will gain attention. That's the only advice I can give if you want to go in this direction. Okay, so most of the data sets are open. You can go to this website and see a lot of things are available there. Okay, so and you can participate in technical forums to understand what is happening around the world. You might find most of these are product related, okay, related to products whatever Schneider has, but it might also give you an opportunity to understand, okay, where I might start focus. Okay, and there are a lot of data sets that are contributed by other fellow researchers around the world. Okay, it might not be a finite information. You might find bits and pieces also, so which also you might use in your upcoming works or researches. So we are betting on the artificial intelligence that is going to come in the future, and we want to prepare our infrastructure ready for it, and also we want to help our customers unlock efficiency and sustainability. That is our mission. Okay, so we are making some small steps here with the help of digital twin, investment in ecostructure power, ecostructure, industrial intelligence, and everything. Okay, it's a very small steps we are doing here, and we also open the doors to you in the form of exchange.sc.com, where you can access or you can post your research to get recognized. Okay, if you're interested to partner with us or co-develop with us, or you want to participate in a research what Schneider does, maybe you can find some links in sc.com, exchange.sc.com. That's what I learned from, because before start of this session, I want to deliver something meaningful for this community to develop further. So that's why that is the information what I got from my internal colleagues, that exchange.sc.com is somewhere the community can benefit from. Okay, so I let you go to this and do your research here. Okay, and today we are based out of Bangalore, and we serve the entire world for power system studies, power system analysis, digital twin, electrical design, power system design. Okay, and our main focus is around data centers, because that is where we are heavily invested in. Okay, and you can, if you want to know more about what Schneider Electric does, you can find in a lot of in our website or YouTube. There are a lot of things available. Okay, any questions? Because I didn't see a lot of people interrupting me. Or any questions in the chat? Yeah.
Sir.
Yeah, just a minute. Yeah, tell me.
Thank you, sir. Very nice presentation.
Yeah.
Digital twin technology, in the case of industries, it is understandable to me.
Okay.
That we can develop a 3D model and we can understand and improve the operation of that industry during the design itself. Otherwise, during operation, we can do.
Yeah.
But in the case of power system, which part of the power system network should be modeled? Okay. Generator or transmission or distribution? Whether we want to have a 3D model, because we do only two-dimensional analysis in ETAP, right?
Yes, exactly.
Then
so,
what part of yes, thanks. Tell me,
yeah,
sir, please.
So today, you see a lot of industries adopting digital twin because industries want to optimize, they want to move faster. Okay, and the entire power system, if I speak about it, is a grid. There is a huge investment that needs to come in. Okay, which needs to come in from the government or a public body. Okay, they need to invest a lot, so which they have not started. But from our perspective, the digital twin is applicable everywhere. Okay, and the digital twin in future, they will communicate with each other. Maybe an industry in Chennai creates its own digital twin. In future, they might share this or connect this digital twin with TNAB digital twin. Okay, so today the investments are happening only in industries, mostly in data centers, because they are the one who want to move fast with AI, move fast and optimize fast with AI. Okay, grid also will come very soon. Don't worry, it will come, because power system analysis is everywhere. Okay, without power system analysis, grid doesn't exist, industry doesn't exist. Okay, so when they start seeing the benefits, or if there is an fast innovation in AI that is going to help or accelerate this digital twin, the adoption will grow in future. Okay, even when we started before 5 years, we did not think that this adoption will be very fast. Okay, because we were just sitting with like somebody asked a question here. We were just sitting with single line diagrams which were doing power system analysis.
Yes.
We never realized, okay, this could open such a big potential for us. Okay, and there are challenges. There are challenges, as I explained. We were not able to have a high fidelity models within ETAP, for which a lot of work is going on. Okay, and even if some of you are want to do some research, I encourage you, because this might give you a turning point here, because high fidelity models which can replicate a real world scenario is the ask of the day. Okay, and if you I know some lot of you are from electrical professors here, the drawbacks of our system analysis, because we are making a lot of assumptions. If this high fidelity models comes into picture, and if the accuracy of the analysis itself improves, the decisions will be better. Okay, so the change is happening, and as the investments are coming in, we are also improving. Okay, so the change has been very fast, because I was doing a presentation for Pushpa Share last year. We were seeing digital twin is a mega trend. Okay, that might change the future, but this year it is not a mega trend. It's a normal. Each and every project we are doing a digital twin. Okay, nobody is asking for a single line diagram printout. Nobody is asking for a power system analysis report. Okay, the PDF reports are gone. It doesn't exist today. Everybody is asking a digital twin. Okay, nobody is asking for a short circuit study report or a load flow analysis report. Okay, before 2 years, even myself, I was producing reports for reliability study and power system study. Today, I'm not doing that. Nobody is asking for it. Okay, maybe in a lesser markets, in a local markets in India, still people are selling power system study reports. Today, no. In a global scale, in the scale of companies what we are working in, everybody is asking, can you give us the digital twin? Okay, even though they see today it is not integratable, they want to prepare for the future. Okay, so any other questions? But the investments will slowly come in. It is faster than we anticipated, so it is going to come. No doubt in that.
Okay, sir. Thank you so much, sir, for your valuable session and engaging and informative regarding the AFDP, sir. Thank you, sir.
Thank you so much, and thanks for the opportunity to address such a wider participants. Okay, so I will remember this forever.
Okay, sir.
Thank you,
sir.
and thanks for the thanks to share the feedback. Okay, because
sure, sir. Participants kindly fill the feedback form posted in the chat box.
Yeah, sure.
Thank
you.
Thank you, Ram Kumar, sir, for your valuable
you.
session.
Thank you.
Thank you so much, sir.
Thank you.
Participants kindly fill the feedback form for the day 1, session 2. The feedback link is posted in chat box. Participants kindly fill the feedback form. Write your name in capital letters. Yes, sir. Those who fill the feedback form, you can leave the meet. Thank you. We will meet you tomorrow. Thank you, one and all. Vimala ma'am, we will stop the recording, ma'am.